and let's do buffer overflow. It's actually buffer overflows, and we didn't finish this one because it didn't work when I tried it. And now I have more knowledge from both doing Hack the Box and also doing some of the so I can feel the hours. You can feel the hours sometimes. Stuff is not as easy to remember. So I think I'm at 9 hours streaming now. And I can feel that. It's starting to be harder to remember some things. But I don't get tired when I do fun things. So I'm going to go check on my kids before we continue, but I'm going to continue. Unless someone wants me to do something else here. I don't think so, it's sleepy time. We'll do fun stuff with the family tomorrow, you know. I've promised my kids not to stream, mostly one of them, in the weekend. But that was some time ago. I think it's more used to it, me doing it now. But I'm usually very busy during the weekends. So, what I was thinking of, let's see. This is the example we just made. ProStar. There it is. So ProStar, we did a few of them. I don't know if I finished this one. It looks like I finished it. I don't know. So compare, these are very simple, but also I had to run them on my computer because of the VM having American keyboard. But I just realized that if I connect to it, if I connect to this virtual machine, not just start it, but connect to it with Netcat, you know, anything, then I can use my keyboard settings. I'm kind of assuming SSH does the same, but I'm thinking this is a very simple, basic, old Linux. Did I even save it? Yeah, I didn't like it really, so I just saved the files. Also, the files telling you about them were down. So what we had to do was to actually go to someone else's GitHub with their solutions and just look at the top to get the code, because you're supposed to have the code for these. I think they seem to look like that. So this looks suddenly very simple, but the problems I had was that I had, you know, extra characters popping in there. I know more about disabling the security features of Kali now. And here when we compiled it, we got a different code. So that's fun. And we did it with no stack protector, no pi M32. And it burns but gets, which is what we're really doing there. Stack 3 compiled. Right. Yeah. So this is EDB. It's pre-installed with Kali, at least phone that I'm using. and it is like the X64 DBG one, but for Linux. It's a graphical one, and it's also dark mode, more modern. What I'm not looking forward to is actually continuing the path on TryHackMe, because the room that was actually in my path. So let's duplicate this tab and go back on the first one. So I should ask Tiberius if he could fix a new VM for this. Because it's using old stuff. And there was no way. Immunity debugger here. And it's Windows 7 anyway. It's not Windows XP at least. So when I did this, it says here, note that this ROM does not teach buffer overflow from scratch. Then it was like, okay, so why didn't this is a path? I've been on all the paths before this. How come there's no information? And then I searched and I found this buffer overflows room, but I've also been reading a lot of other stuff. So much other stuff now. Yeah, so I think I will do this. Let's do this. So we have 2 buffer overflows left in this one. And I think these are Linux. Yeah, I think so. And also we have different alternatives than their code if we want. And we can do MS of Venom, and then we'll see if we can do this one. I'm just not looking forward to streaming tiny text. It's not fun, because I want people to be able to see. And I hate it myself when someone is streaming in a tiny text. It's horrible when you can't see. Even if they may even have 4K screens and I have 1080, and then I can't see, you know. And maybe I'm looking at on my phone even. So I'm checking all my kids. And then we're doing this. And I know much more now. We've explored. And if I still feel that this is there's something, we'll do Protostar first. Because Protostar is more steps in between. This one just skipped a million steps. So we're overwriting a function pointer, and then we're suddenly just, yeah, it was just missing a lot of steps. So overwriting a variable, very basic. Then overwriting a pointer, function pointer, very basic too. And then doing a full buffer overflow without any instructions. So that's why we hopped over to Hack the Box and Protostar. So I'll be back for this example. Look at Overflows 3 folder. Yeah, right, so we need to start this. Start the machine. And we'll have to switch VPNs. So let's actually clean out a few things too. So this is just one we've been using for RDP. This is exploit. No, this is pattern. This stuff we can have this one up. We'll be doing that. We could clear it though. And then we have a Venom. So let's actually do we won't be using this because I have one. I'm thinking of how I will rewrite the script. So, but Actually, let's see. It's called. Let's call it pattern. So pattern, and here we have M's of Venom, and here we have well, Nat Cat. Let's see, and this could make it quicker, right? So this directory we won't be using right now, and this file that we downloaded here, it's moved. This is just an example, and it's done. The script we have on in our notes. So let's actually oh my god. So maybe it's good that Hack the Buck has two directories. Buffer overflows. And it's overflow 3. Oh, so we have it here. We've tested stuff. Good. Let's actually switch VPN. So now let's just we can keep this one. No, let's close it. Let's close it. We can open it again. Or we can even the code.
Madam Fabulous says,
are you just trying to stream long enough you can raid Theo?
Theo, will he start streaming later? No, I don't know anything about his streaming plans, sorry. Oh, what I just realized is I forgot my headphone downstairs. I'll just go and get it. Just 2 seconds. There. So, yeah, because even if I have this mic off, if I go to the bathroom, I'm leaving it outside. You don't want to have some noises on stream. So now I'm curious. I have to see. So I'm seriously streaming until I feel like stopping today, because it's Friday. I don't have to get up tomorrow, and I'll probably not stream during the whole weekend because of I promised my kids,
Hell yeah.
So I don't want to stop yet. I'm not gonna stop yet. I might get too tired finally. In a few hours. I don't know. It's like 45 minutes to midnight. So we started the machine. Let's just remember this room a bit. So it was some time since I did this. I'm actually going to change the stream. No, I'm not. Leave it. Actually, it's kind of... Let's do buffer overflows at TryHackMe. There. And I'm just changing it on Twitch because it's very simple to do. It's not simple to do on YouTube. So I can just change it in OBS. So in this room we aim to explore stack buffer overflows and mitigations. We're using R2, which is good. I like R2. So they're just explaining how the stack works, and in a bit of a messy way explaining things. So, but they are explaining things, which they're not explaining all the things. That's why I hopped from here, really. Anyway, a whole section on endianness. Well, it's short. Overriding variables. What's this? Okay, yeah, overriding too much of them, right? So they have an end and a buffer, and it overwrites towards the stack bottom. Even though the stack grows downwards, the data copied into the buffer is copied from lower to higher addresses. And that's why we can do it. So, our writing function pointers, this was a second task here to actually do something. And this was very simple too. I'm thinking, should I redo this? Let's look at the notes. I must have notes for this. Maybe I didn't make notes. If I didn't, maybe I should. So let's see. I think I have notes. So this should be overflow 2, right? First of all, how did they want us to connect to the machine? Was this SSH? I'm assuming. Okay, so without this we wouldn't have gotten far, right? User 1 password. It's not hard to remember, but without knowing it. So let's make a new tab, and let's actually call it SSH, right? And let's do SSH. User 1 at copying the IP there, and we've connected a lot of times to this, testing things, and I've not been able to stream for a long time at a time, just short ones. And I think we've been reconnecting extra to test things, right? So, user 1 password there. Amazon Linux 2. So, we have all the directories here. And these we have copied to the machine. So we have them here too. And it's nice to be able to compare how it looks in memory on the machine and on here. So maybe I should call this local. Let's see the notes now. And so this is Protostar. If I click here, I should hop to boxes, right? And I should minimize that, I'll forget it. No, I'm not sure I would put it here. So there are too much things here. I don't think that's a good place to put it. Here's the protostar one that we have here. And here we have this example. Yeah, I don't really like to have this here either. A whole like tree for one file that's shorter than any of the files we have down here with the buffer overflow stuff. Here it is. This is probably a better way to put it. And have an examples folder there. So I'm just going to do this. Let's rename. Control A. No, I did rename. Control C and open. And I'm going to just drag this. This didn't used to work, so now it works. Me happy. And let's put it here. And so if we ever have other stuff in HTTP Academy, they're welcome to hop in here, but this one won't have any contents. Just quickly see that this is just a folder, and this is what we're deleting, not the file that's here. Come on, I did click and delete. Delete. And it has the same name. And here we have protostar. And it is vulhub, but it is mostly an example of buffer overflow. So let's put it, come on, buffer overflow. Let's make a new folder, examples, because this is more useful for us, and we want usefulness more than we want correctness, right? So there are the Python files. Linux example is an example. Here's protostar links. It can be here. Temp. Oh. Okay, we can delete this. This is a copy, old copy. It will be synced to the server now, or to. Oh, and here are the full TryHackMe rooms here. Train links 64 awesome. What? And here's. So I thought I had more examples. We'll find them. And also this. Let's just quickly go through this and see if we have anything useful. F3, open file. Okay. Yeah, so the only useful things I see here is a short list of these commands. The rest is like, I don't want to say too easy. By the way, X free RDP. I wonder if I have it somewhere in here. the command I have in my history. What if my machine crashes and never comes back, you know? And I have this perfect command that I always use in my history. It's time to take a backup of my history or export it again. And I've been thinking about finding a way to change the size of it to last, hopefully, maybe forever. I don't know why it's limited. I don't like it. So I was going to put this in this file actually. So shortcuts, and let's just level 3 header, yeah. And I'm kind of close on that. We are done with Windows for now. This file I'm deleting. So I already have these in my notes. Find string, listen. Nah, we don't need that. It's better to look at all of it. I like seeing the overview. I didn't make any notes about netstat at all though. Let's add that. So it's a good reminder. Here. So the header here is there a buffer overflow? Look for open ports when the program is running, and try try sending data. Well, that's enough, right? So let's put in netstat here. So netstat, hey, that's enough. So we can remove. This just reminded me about history. These I already have in here. Netstat, netcat, venom. So there's, as a breakpoint to Python exploit. Breakpoint. So this is not what I did. So this is interesting. You see, this is why we read this. And also this list could be nice. So let's just delete these. And breakpoint. So now we're not in there anymore. So this is actually idle. We did this in. Let's go to Python. Programming. Python. Debugging. Breakpoints. So I found another way to use them though. And then we have all of the commands bit done. But this is like a general overview. And then we close that. I should have clicked the path there to hop back up again though first. Buffer overflow. So overview. The steps of whatever. Definitely 3, right? Fuzzing parameters, controlling EIP, identifying bad character, finding return instruction. Finding the shellcode address, right? Because it's not always one of them. Jumping to shellcode. Well, that's good enough. Let's put this after the basic introduction of what it is, what is. And then we do steps, and then learning how to do it. Basic information about the computer, and how to find things in memory. Is there a buffer overflow? Yeah, so we could put it here too, under buffer overflow. Maybe this is a better place for the overview, but that is level 4 header now. Yeah, so let's do it here. Fuzzing parameters, yeah. And we could change these to our names for them, but that doesn't matter. So we don't want it twice. That's better. Goody. Good enough. Let's now delete this one. Didn't I close it? Did I have it up twice? Delete. And we found the notes. That's what we were aiming for here. And let's go to them. TCM buffer overflow 1 though is not here, and these are supposed to go into examples, and we can minimize ProtStar for now. And let's make a new folder called THM buffer overflows. And that's what this room is called. And then we have number 1, overflow 1. Overflow 2. Overflow 3. So I'm making these folders. Maybe I shouldn't make folders. Maybe it's just one file for each. That's like overdoing it. So what do you think? I was going to make a note, I think. Call that. Yeah, let's actually delete this again. I'm regretting. So now we don't need a long name because it's already in there. So 1 is empty. 2 is renaming the. Here we have the code. So seriously, I don't really like what is here. This is like not useful. We don't need to know this. We don't need to know the file layout. We need to know the code for the file and possibly what its name is, right? Though I kind of regret not remembering. Yeah, so let's actually let's do this. No? There. So, see? We can keep this line, I guess. So, and this is sh shell. Oh gosh. Oh gosh, it's so simple. Yeah, this is how simple it was. Now I'm curious. I need to know what 1 is. So 1. It's not Endian, it's overriding variables must be 1. So this is an image, meaning we don't want that. But we have it right here. So let's cd O1 and let's cat there, and then we have the code. We don't really need to know this. But I did put it on the last one, right? No. I tried selecting one line up, it hopped. So does it hops. So I want me wants all the information. Therefore we get all the information when we can, and we can. So let's do it. This is C. And we have all the code. We know what files are in the directory. So let's run it. Let's first of all look at the code. So we have an int variable. Oh, I know I didn't make notes because it's identical with one of the ProStar ones. It's identical. Let's just do it. So we just need to write 14 characters. But it's 0, so we'll do 15. So let's run it first. Just int. Yeah, so ./i and you've changed the value of the variable. So I'm guessing we'll run it once and say 1, 2, just to have both outputs, right? So then we have done the first one. But I guess here, there. I guess we want the basic stuff in the notes too. So I'm going to switch this around. So the first one is the one with the failing attempt, and then we have that one running it and getting buffer overflow. On the code. The files. So very basic, very simple. So 13 characters is what really fits, but since it will be terminated with null, we need to do 15 for it. So I don't want to explain it several times. But let's do it. So if someone sees my notes and sees this, we have to do 15 chars, though 14 actually overrides. What's the variable name? The int variable, but with the string terminating null, meaning the value doesn't change. So and we'd get try again. So I think I will actually copy this text to another place where I have the same oh my god, this is long. Yeah, so these are examples, leave them as they are. I don't want to edit them, but what I want to have in a nice way is the actual buffer overflow nodes. I guess we can close security features, though it's very relevant. Still, let's keep it up. We need to make a Windows 10 VM that has not a lot of security, and I only know how to turn off some things in Linux, so I'll have to learn how to do it. Here is the comment I want to change. I went to F40 again and try again. So as you can see, this is the same, but it's a worse comment. And I don't have to prove that it's correct. It's such a basic thing. So this is a better, shorter version. So 2. So let's hop over to 2. cd dot clear lslay cd overflow to lslay cat dot c, and now we have a bit longer code here. And let's do the same format, and I don't have to do it again, I know. And I already did this, so I don't need to do it again. We already have the code here. Why does it say actually 2? Because this is not, this is 1, right? So this is 1. LSLA, LSLA, you see? So the 2, that's why I didn't have a 1. Because 2 contains both. And it's a bit messy. So let's see, we remove whatever is 1 from this. Oh, so now there is 1. Oh, I'm actually compiling it. Okay. Right, I know what I did. I compiled it with a value of 1. So it was equals 1 instead. So we could crash it with 14 characters. Because I thought it was like bad. Here we go to Overflow 2. This is where it actually starts. And this is where it will match what we have now. So yeah, so I'm going to actually do this. And I'm going to use what I just had made. So, see? And there. And then it's run. After the LSLA, we do nano func pointer C. So I was editing it there. I was just looking at it. Test. This is the normal function. And then we run it again. I don't know why I nanoed it there. Segmentation faults. And then I was learning how to do stuff, and I tried this. I didn't get anything out of that, so we're going to stop. And here is where we start GDB. So that's where we actually get. Then we have the licensing information. Manual, documentation, help. So I do that. Symbolize, I just deleted a few lines. So break main, run starting program. Let's actually look at the code instead of looking at what we did before. So with newfound knowledge, it will be clearer. So actually, why not look at the code with coloring, right, when we can? So there's a special function, there's a normal function, and there's another function. And as default, this pointer in the main points to normal. And we also have a char buffer. So what I was trying to do here, and I had to learn how to do it by testing a lot of things, and all of them don't have to be in the notes because it's just a mess when you didn't get anything from it. So let's cut down a bit so it's actually what's useful. for me and someone else trying to learn this, a good example of it. So char buffer 14. We knew that we have to overwrite 14, but after that we need, I didn't know then what I know now, that it's very easy to list the functions, right? Because I didn't know the commands, and I tested different help commands, I'm sure, here at the start. So here's the GDB start. Let's actually break this up. So here I started with GDB, starting GDB for probably the first time, maybe the first time. This is not SH, this is not SH. Want a bit of color in there, even if it's not really logical. So break main, run. Missing separate debug infos, breakpoint 1 in main. And buffer. Cannot find. So this was not useful. This is not useful. Next. So next. No line number infer exited normally. And then I'm trying these commands that I found somewhere. Yeah. Next. Exit. So here is my first try at doing help. And all the help information that I got is now in the GDB file here. So here is all the GDB information that I gained until now, all the commands. So let's cut this from here and not have it mess up the log, right? So here we're again starting a GDB func pointer after having quit and stuff. And so I'm doing break main run. Well, let's leave that one on, I guess. Break main run. Info frame. So here's the first actual command that gives something, some kind of information, but it's not what I wanted really. So I'm just testing the commands. Run again. I wanted to restart it here. Breakpoint to main, info frame. Here we have actual questions. The first time I test getting memory, then I get the first actual list where I get the names. Yeah, I'm thinking we don't have to save all of this. Let's actually, also I catted. So that kind of killed it. I was testing ways to send data in there. We're connecting again, fresh. We're getting the OLED again. So now I actually have something here. This is the actual run of it. That's useful. So let's cut this up kind of far. So let's see, GDB. So here we have GDB again. So we do info functions. We get all functions. Why do I quit? Oh, okay. So quit. Let's do quit, so it is obvious for this first example. LSLA. So I already have this in my notes by now. And here let's actually split this up, because this is actual run that's yeah, so here I am. This is a special function. Why is this here? Why is this here? So we're running the different functions here. Let's just put some space between here. So this is not part of it, it's just afterwards. So we're getting so what did I do for the first? What did I call it? Running it and getting buffer overflow. So that's the last bit. Getting the addresses of the other functions. Using GDB. And then we have test run. Did I do anything here? The code, the files, running it and getting. So there was both in the same. So let's do test run. The code. The files. So I think I call it the files here too, right? So it's logical. So we don't have to have the cat line in there, it's just leave. Oops. So this line is important because we see what directory we're in, right? So that's why I keep it. Will look odd with just the files. And here also we can remove these. So, and any comments here? So let's actually make this a bit prettier by deleting the prompt afterwards, just like we did for the others. It doesn't have a new line. So these have \n, this one doesn't. That's why. Running it and redirecting directing execution by changing the function pointer there, and running it and redirecting execution by changing function pointer through buffer overflow there. So other normal special. So I usually put these things outside that are interesting. Normal we don't need. Function addresses. So, it's midnight in 1 minute. I don't think I get less tired from this. So this is 32.
Velvety Sweetness says.
Best viewers on web link.
So
Fixerbot says.
what
Message removed.
I just realized I didn't say goodnight to anyone. So let's see.
Finn with Gun says.
Howdy.
Hi Finn. Just a second, I'm just saying good night. There. So realizing it's late. But I got a message not that long ago, so there. So I'm good. I've been streaming for, it looks like it's a 1.5 hour, but it's actually, well, I started at before 13 my time, so it's closing up to a few hours now. We had a crash. Now I'm curious. Has it said anything? Yeah, it says 1 hour 27 minutes there. Yeah, so before, if I look back in chat, 9 hours and 30 minutes before it crashed. So it was about 9:45. Yeah, so we have 10 extra hours, so we're closing up to 12 hours streaming now. Buffer overflow all the time.
Dang. Out here grinding.
Yeah, so I've been doing the Hack the Box Academy rooms on Buffer Overflow, and now I'm doing the TryHackMe here. So we did these, Linux and Windows, but I only did this today. I didn't. The Linux one was already finished, and I think I started a bit with this. So, after this one we're doing this, but this is Windows, and this one had a VM. This one does too, it's just bad. Low res, not very stream friendly. So how are you? Having a great Friday night. So this one is done, this one done, and also notes written. So I don't remember how much I did on this, but I know that I've looked at it before, so we're going to look at it too. Now at least we have good notes for these, and even though they're very simple, it's always nice to have good notes and examples here, because I might forget this in the future and be like, right, how did I do this, you know? I haven't done this in a lot of time. So 1 hour 3 minutes here when I check in on it. So I just can't click the more time. It was very
I don't
nice,
know
actually.
anything about buffer overflow, haha. Maybe I should join and learn about it.
Join in here and learn. So let's say that these are much more step by step, and this one here it does 2 very simple ones and then jumps without explaining. So this is why I've done other stuff. I've also done something called Protostar 2, but not all of it, just a few. So I'm thinking I'll finish those up too. Protostar 2 also had other things, not only buffer overflow. So it's this the vulnerable is cool, right? Yeah, you remove that bit of the information really. Protostar. So here we have. Yeah, so these have better notes for the first ones. But then I think it starts going long. Maybe not. Yeah, so this feels like ancient times now. Let's see the dates of these files. Show in Explorer. Let's see. So you see, this is ancient times. It's a month ago. I've been doing this for over a month now, but I've been doing other stuff too. It's mostly just buffer overflow for a month. That sounds very funny. So there will also be a overflow far after this, and this is where you can see that this one takes it more step by step, and this is just boom, hops here in the difficulty without explaining anything. So now I'm going to see how much I did of this, but let's start with just actually looking at the machine. So right, this is a sued one. So that's it. Let's actually do this.
A mediocre dev says.
I have to thank you. I got the idea to use Obsidian from here and I am loving it.
Yeah, great. Obsidian is actually very good. Yeah. So let's do sued binary here, because that's kind of good if you have examples and you want to see, oh, how did I do with the sued binary, you know. I will also have to fix the examples from here. This is do I have like a hint? Yeah. Just a sec. Yeah, so this is examples, new folder, HTB A Linux. Should I do buff? Let's do buffer overflow. So public nodes, I have to think. Try and make it easy too. So, and also let's rename it to just buffer overflow. And HTTPA is Hackerbox Academy, but I don't want to type it out because it's long. Yeah, And this is the room name. So I'm a bit disappointed on myself for not making better notes on these actually, and I know it's a bit of a mess. But I just copied this from the main buffer overflow file. So so I've started using a format here: files, the code, running and getting buffer overflow, and this one was a bit more complex. Test run, getting addresses of the functions, redirecting to this function. So that's this. Then the suite one now. Let's start with running it and trying to remember, because it was might have been a month ago. So we're going to read the secret text, which only user 2 has access to, and the suite bit is set on this user 2 binary, so we're supposed to get a shell with this one. And I did this not so long ago, but I don't have the example. So this is when you notice that you should have made examples. I just made this examples folder now. And moved things I already had in there and started fixing the THM ones. So we have the C code, making it all easier. So let's cat b dot, and going to copy both of these, and let's start making better notes of this. And we don't need this start that it has here already, so we're going to actually delete that line.
Dankbriar
Change
says.
this to C.
Cheap viewers on. Web link.
Another one of those.
Fixerbot says. Message removed.
So files. Should I remove the message removed, or is it kind of good to know that it was removed? I said the files before. Let's be logical. The code. Right. So here we can see the code. We have a buffer. And then we do a string copy, which is not a safe. Copying our, as we can see here, argv1, the argument to the to the program, and it prints it after copying it into the buffer. So just shortly, we can do how much text we want as this argument, and when it's here in the function, a zero copy has no check. So this could be 2000 characters and it's just a buffer of, or this could be 2000 characters and the buffer just holds 140. So we just need to just use this. And we're going to make, of course, an SUID thingy. And there's code in here. So I think I will just skip the old things because I know this better now. Yeah, and you see here I have the code. Yeah, so this is just what we just pasted, but in a better way. And then we have the code again. And then this is what they give us. To open a basic shell. So this is what we have from the room, from the, we're given this. And this I disassembled this. I put this in a file and then I opened it in R2 and did a PDF. Just managed to disassemble it. It was nice, even though it's not a full executable ELF file or anything. And this is just an explanation of what this does. Opening the C program with GDB. So let's actually We don't need to do this. I know this now. At this point, I was just learning this. So start. So this is the first time I run info registers. Maybe, no, probably not. So this is not any useful information for this program, really. So I'm thinking we'll just not do this. Yeah, so this was just a short example of GDB, really. Let's just delete it. If I forget it totally, I think I might have some examples on the bottom here, don't I? Oh gosh, sorry, clicking all over the place. Examples, printing variables. Yeah, so I have a few examples here. We can put this one here too. Oh look, here I have notes to myself. You can only debug a set you with. Yeah, right. I remember this. I just wrote this 1 or 2 days ago. So, very nice of me to make it red so that I could remember this now when I've been streaming for 12 hours. You can only debug a set you with or a set.jit program where the debugger is running as root. And we're not root, right? Otherwise, you could just call GDB on binsu and have root. If you run GDB as root, you'll be able to run your program, but you'll only be observing its behavior when running as root. If you need to debug a program when it's not started by root, start the program outside GDB, make it pause in some fashion before getting to the troublesome part, and attach the process in GDB. Attach the process ID. So, and here's the source of this text here. So I had some problems before I found this. It was like, why is this not working as I expected, you know? Let's put examples here. And it's this. So I'll just cut this bit. I was going to delete it, but let's put it here as an extra example. We have the automatic breakpoint, variable examples, printing words. So opening, well, C program doesn't help. Opening a program is not there now. So this is actually, we could do def q, but that's not interesting. So we have info functions, the functions, info registers, no registers now, that's not useful information. A start, temporary breakpoint in main, q, debugging session is active, exit. Yeah, so maybe the start and that info registers. Yeah, okay, let's keep it, but we don't need this line, that's useless. And we don't need, well, let's show it. There, let's show it. This is relevant. Right. So we cut the best we didn't want. So as I was exploring here, these notes with the images, they are more connected to actually EDB, right? Example stack 3. So let's actually remove it from stack 3. No, let's keep it in stack 3. We're going to overflow 3. So there for a second, this can be like this. I don't care. I don't want to redo all the notes just because I'm found something better, you know. And now we haven't done GDB first, so we don't have to say this. Opening in R2 with debugging. With R2. So it's called buffer overflow. Number buffer overflow 3. Process with PID started. Attach. Yeah, so this is more informational, not just you can get help or my licenses, whatever, you know. Architecture. Anyway, we do AAA. This is like always the same. So I think I will actually dot this bit because it's not really interesting. Also the IA, I'm going to skip the IA bit because it's long and it's not useful. I'm also going to skip S, AFL on the other hand. It's interesting. So now we have a list of the functions. We can skip the grep main one. It was just to show that you can grep stuff. And it's not interesting for the example, it's more interesting for... then since these are colored, I switched to images because we can't copy paste colors. So PDF is disassemble the main function. And it looks less pretty, and this is more colorful too, really. In R2, so R2 is very nice and pretty. Then we have buffer overflow. Right. So we're just testing something here. I'm thinking, why am I doing this? I'm doing knobs, 110 knobs. So where did this come from? There's information missing here. So I'm going to redo this. Am I just testing input? Hello,
67 yard 6372 says.
Yellow.
Yeah, there are yellow numbers here. So, yeah, as you can see, I'm just testing stuff here. Let's actually use our notes. Use the buffer overflow notes that I made through apparently the last month, and follow these to fix this. Get this buffer overflow here. So we have a SUID binary.
Do you know about Arduino?
Yeah, I use Arduino for some things. We have a robot here that you can control. It's using an Arduino robot arm. But I'm probably a bit too tired to put the cameras and everything to use it right now. But there's usually a redeem. It's active, but I'm sorry, if you click it now, I won't for it. Another day. It's past midnight and I've been streaming for 12 hours, so... but you're very welcome in. And we do electronics and stuff here too. So what do I have within reach? That's electronics. Like a mess
Fixerbot says.
on my table. We also have pies.
New follower 67 yard 6372.
We also have pies.
Less than 3.
That we play with. I can show you the robot arm. That's not hard.
New follower Finn with gun. Less than 3.
Fan, were you not following? Thank you very much for the follows, guys. So I actually put it in a box so it won't get so dusty. because it keeps getting dusty when it's on the desk. But you have this robot arm that you can control from stream. It can also rotate. It has this arm you can grip with. So for now, it's in a box.
67 Yarg 6372 says.
Well, that is cool.
Yeah, so another day, right? Just off for it another day. So I have so many electronics things there. So this box is just LEDs. It's all LEDs, different kinds of LEDs. So we have other things here too. Some robot thingies, wheels thingies. So there. So I have a oscilloscope here too and thingies. Right, so we've also used these tiny ones for making reverse shell. These have USB. So I always forget the name of them. Digisparks. So if you put them into my USB, it will try to connect to a reverse shell on my Kali machine. So if it's on, and I happen to have English keyboard because I haven't fixed it for Swedish keyboard. So using Swedish keyboard is a security feature. Didn't know that before. So we do lots of different stuff. Let's see, let's continue. Let's use my notes for buffer overflow and actually overflow this buffer by sending it an argument and testing it. So the way that we test this buffer is that we will debug it and check the memory address. And we will do this in this VM that has security features turned off. And this executable is also made with security features turned off. So the modern security features shouldn't be working here, right? They should be like easy for learning. So if we think here, we don't read the first bit here, but we go to the actual instructions. But this is online. You can read my notes so far in exploring buffer overflow. So first, is there a buffer overflow? Now we know it is because we have the code. But we know the buffer overflow is an argument, meaning something like this. We'll be able to use something like this. Alright, yeah, I remember learning this, that I can use backticks if I use double backticks here. Then I can use single backticks in the string. So if we were to run something for this now, we would use this. So first, we can just test to see how many characters. But we have the code, so we know it's 140, right? But we don't know exactly what is after these 140 and how the memory is organized and things like that. And recently I've been using the graphical ones, so it's nice now to go back and test this in a basic, connected to another machine that has whatever tools it has on it, and well, we will be able to use tools on our Kali machine. of Venom, Metasploit scripts to create patterns, things like that. Oh, we also have these files locally, so maybe we should close that tab. But it's fun sometimes to see how it works on this computer, a modern Kali machine, compared to this dumbed down version, right? Even if it's an old executable, it's not compiled with security features. So if I were to paste this and the program here, is buffer overflow, right? And then we do well, actually, let's do the better one. Let's do dollar parenthesis because it's much prettier. I don't like the backticks there. And then we have Python, do this command within these two. Then we print a number of A's, and let's do let's skip this bit for now. This is just an example, you know. So here is the end of the print command. So the number of A's we want to print is 200, right? So if we do 200 and the buffer is 140, we will overflow the buffer quite a lot. So we should get an error from this. We get a segmentation fault. We don't get an address or anything when we do this. So let's run this in R2. And I'm sure R2 is on this because that's the suggested tool. So we do R2 and actually we just go up and we add R2 to the start here. I think that's how we do it. And to make sure, because I don't remember the syntax since I haven't used this for some time now. So right, we can also do A. We can do D. So I guess that D is what we will do. But we can do A and D both. Now I'm curious how it will change, possibly how it works. Will it change what else we do, and what will happen if we just do R2? So now I need to know. Just run it like this, right? And I'm looking at this and seeing to run it. I don't know why I misspelled it. All the others are correctly spelled. So I'm thinking DC is what we will maybe do, but this is, I'm not sure. A, I see, IA. Yeah, these are the examples. So yes, so we have this already. We don't need to save it in the other spot. File PDF without the nice coloring. PXA help. Yeah. I'm thinking that the Linux example I had was probably exactly this, but I think it might be GDB, that it didn't have R2, that one, that VM. So it's good to know all the tools. So as far as I can see from this, to run it, it's kind of funny thing that I don't know that already exactly. And why do I have an I here? I probably typed it in, thought it was in another. Actually, let's undo. Yes, I think I deleted something here by mistake by typing an I on top of text. So I could. So there are good things with having a Git, you know. So this is on my GitHub, so I can see what changes I made to this file, if I want to. Removed something here, question mark. So I can see I have the syntaxes here, so maybe not. Maybe not. Anyway, to continue execution is DC. So we're going to test it. Oh, cannot open. So now we're doing D, and then it works. Okay. And now we're testing DC. I'm thinking I will need to do AA first. Okay, okay. So first of all, let's quit. And one big pro with R2 compared to GDB is it has a default yes, so I just need enter. I don't have to click yes or Y. So I'm sure OOD, yeah, so this is what I wanted. OD arguments. This is what I usually do. So instead of quitting there, I should have run this OOD instead. So now let's d dash a, and let's do 300, and now we have it more loaded more. And if we do DC now, we get the same thing, so it didn't matter. With signal 11, error number 0, address 000. You know, this is not a nice thingy error. So let's do OOD, and let's copy this bit. Here, and let's do 500. So let's just see if we get the same if we'll make a lower one. Yeah, so I'm kind of thinking, oh no. So what if I just do OOD now? What happens then? File will be reopened in read-write mode. So DC. What about the start? I think it was not the same one, right? It didn't do anything. So this one has short commands. I've used GDB more now because the last one I did only had it. So now I'm like, I remember doing this, but how? I'm trying to think what the best way is. We can also explore it, the local copy I have with the graphical DB tool. So what I haven't done here, I've only looked at its own help. So I'm kind of thinking, let's do this. So copy and ChatGPT. I'm making a document on R2. I have looked to help and found some useful commands. What would you add? And we can go and also check the actual documentation that I have not yet done on R2, which is kind of like the first thing you should do, right? But I want to test to visual mode, visual function graph, seek command. Seek. What is seek? Move to a specific offset or symbol. Help command. Yeah, help. It's in my list later, lower down. Patching. So we can patch things. Cool. Metadata. Call graph. So data analysis. Search for string in the binary. How do I start the program? So I didn't mean that, but this is what we already had. DC, yeah. So is there something similar to GDBs? Start adding an automatic breakpoint. Yes. Automatically sent an entry breakpoint. We'll stop at the breakpoint. So I'm sure I could just set a breakpoint. It's really saying no. This is not the same. This is 2 commands. Challenging to find something better, more similar. Yeah, I'm not making a script. So that I would get used to that, and I'm on the machine. I would have to create it every time. No. So so a single command is not helpful if it's not alone. Typing start I can do. Now it's easier to actually do a manual breakpoint. Yeah, so we don't want this. We want this. So I'll look at its other things later, but just doing a db sim main, right? Adding a breakpoint. That's better and more logical than the other one. So I'm just going to do that. So, and then we DC again. Then we DC again. It doesn't stop. DB. So I'm thinking I'm using the wrong thing. Did we do A? I think so, because it is, we did A, capital A at the start. That's the same thing. So this is what happens with these non-graphical ones. You get so far up to scroll that you don't remember what you were doing. So I really do like the graphical ones. So this is where we started it. No, we started it here because the first one didn't do anything. Cannot open, it said, because we need the D then. Yeah, so also the arguments for R2 there. So let's actually quit. And let's do R2H. And let's check the basic syntax. So we have P per RSpitz file adder. And D is one of the ones here. Without opening a file, read from stdin. Debug the executable file or running process ID. And A is to run a command analyze reference code. So if we do D and A, that's what I know so far. So I should probably read the docs. But now I'm going to skip this and probably do GDB because I feel unfortunately more comfortable. It's not as pretty, but I've been using it more recently. And what we're going to do is to actually look at this Linux example here. And I will just quickly look. So R2 might be prettier in colors, but I see why people use this. So you just write run and then the argument, instead of like, what was the thing I should write? And you don't have to do a D when you start it. Q is just quiet to not get those messages at the start. Oh, this is the offset. Here Q is query. So I was in the wrong program. Yeah, so this is the buff one. And obviously Linux, the Linux one. So I'm thinking, why did I do this? Here anyway, we have the simple run commands here with the code and everything. So let's try GDB instead, because because here we also have the full run commands from this one. So we don't need that. So first of all, what we want is a clean. We want a buffer overflow crash where we can see the address. If we can't get that, then we can't do anything, you know. So let's see here. If I scroll up, I'm thinking I'll do a clear so it's not so messy. We have this saved. I think I'm quite kind of sure I saved this. Actually now, when I'm not, I don't remember it, you know. Let's actually look at this. Well, it looks like it's working. It's working. Oh well. I guess we'll run this, because why not? So why do I have this here? Will this make it crash? So yes, it makes it crash. I just added characters until it crashed there. So we don't see it though. So if we do gdb dot, come on tab, so gdb buff, yeah, no dot slash. Though why wouldn't it handle it? I don't know. So I did actually do R2 here. Do the same thing. Yeah, so I'm going to use, good thing I didn't delete this, because why? Yeah, let's practice R2 since that's what I had worse. Don't waste your time. So I did AAA on this. Let's do it all again, though it's useless, you know. We don't need this, so we can do PDF at main, and we already have this in there as images in the notes. I'm actually going to delete a few things from the notes. So now I'm going to get even more confused. If I do DC now, yeah, so we're getting the same thing. So what I got in my, here's a program output, program that echoes out your input. So I didn't have anything here. So is this not connected? So we started it with an argument, right? So why would we get different output? So I'm actually going to delete these because they're already above in image form. Just appear. And we have AFL here without an argument. test for buffer overflow, and we got buffer overflow but no address. Let's actually add so let's see. So, am I blind? Probably. So much text now. DC quit. I check the output. Here is where it's run. So, it's the thing above there. So if we paste it and just look at them side by side, we don't really need this one because it's identical, but then we also have the output from the system. Then what we need is the address too, right? So that is not helpful yet. Looking at the program with R2. It's not really debugging. So we're disassembling it. We got a buffer overflow, so we know it's possible to get the segmentation fault. But this machine gives it differently. So yeah, it's 1 o'clock. We'll see how long I will go. I want to fix this at least. So I know I was very close with this one, but since I don't remember, I really need to repeat it, because if I had remembered, then I wouldn't need to repeat it, but now I do. So all of the things here. So this address, it's just nothing there. Let's actually start looking at the memory, right? So we know what we sent there. Let's actually do the A's again. I can't up to that, but let's queue. Yes. And let's go. Didn't I send a lot of A's here? This is also with the A one. So oh, this is so annoying. So I can't really see the start is here though. There's so much information I would like to not have. Good morning, pal is very extremely not important to have. Yes, it is morning now. So the AA is done already here in this case. I'm thinking if we just run this with DC, we get so let's let the computer tell me what this means, right? So please explain the error. So don't analyze the payload. Better. Because the programmer segmentation fault. Yeah, but I didn't say segmentation fault. It said with signal 11. Signal 11 error number 0. Address 000. So it is getting a buffer overflow. It should be. Segmentation fault. So it doesn't say that anywhere. So why doesn't it do it? Couldn't it be nice to say segmentation fault? Signal 11 is segmentation fault. Okay. So the memory address is not good. But why is it zeros when I send it A's? Ask you to want to kill the process. Takes the process crashed you. Key warning message. Invalid range. Or to try to analyze part of memory that are not mapped. Invalid address. Understand the root cause. With command called drpxrsp. Can explore the state of the program before crash by inspecting the disable auto analysis. Yeah, so we didn't have the payload on this one, and still I also know how to check the payload. Maybe I'm getting tired. Then manual analyze as needed inside artificial. So what I really wanted to know, and what we found at once, is that signal 11 is segmentation fault, right? So signal 11 is segmentation fault. That's the new important information that I did not know. And that was really odd for me to try and just randomly get from this. So I'm actually copying the whole text. I already copied it, right? So I can just paste it. We don't want to have this line. So all this crap. So let's dot it out there. And then we do signal 11 means segmentation fault. So and likely buffer overflow there. So let's just do it again, and do it with some better numbers. So what my problem with this is that it doesn't get a nice address. So we'll have to look at it. Actually, let's look at the old things. Right, so where did I find the address? Because I did, you know. So DC AFL AAA AFL DC, just running it, hit breakpoint. So where's the breakpoint added? So it's not complete this. So DS step, check registers again. DB, check the breakpoints, adding a breakpoint. So here we add another one, and when we have two. We can also check just generally the memory. DR. Yeah, right, let's actually do DR here. I'm not sure if it can do it. I think it could probably do it since it's crashed. So the registers. So what is RIP? So why doesn't it tell us what RIP is? This is just 0. I was assuming this is RIP. So RIP is actually not that. So 00400 is, this is not A's. And we just sent A's now. We sent more A's than I thought we would need. But we can see here, this is A's. RIP is A's. It can't possibly hop to 41, 41, 41, 41 and functioning there for 2 seconds and then crashing. Oh, I guess we'll try something else. If I can avoid stepping through it all the way, you know, to find it. And I need to find efficient ways of doing this with command line tools that might be on a box. So I know that I like the PXA better. So here's the PXA. So I'm going to copy the different alternatives. Oh gosh, yeah. So there's all the alternatives. And then we copy this and put it at the very end of the GDB notes. Memory output examples there, and let's go back and let's see between these. Let's just see that we don't have anything. This is PXA, so I ended up with PXA because at RSP plus 100 PXA. So I'm like, why is the same command giving different output? So I was testing different outputs here. I was testing this didn't work, right? So here's the PXI. Just compare that these are the same. No time passed between these, right? So we have the same values. We don't need it twice. The other examples that I didn't like, they don't have to be in here. So we just want the clear information here. DR registers shall stop at signal 28, and so comparing RIP to ours, it is not the same, but it's very close. Ours is 563. Otherwise it's the same. DS. So we're stepping more instructions here. We're looking at PXA again. DS, stepping another step, looking at the registers. Yeah, I remember this being... So I've been doing this for more than an hour now, right? stepping 2 steps. And RRP. Yeah, so we're in a totally different place in memory. And this is a error message, so we deleting it. And I was typing the wrong thing. DC, DS, hit breakpoint. Yeah, I was doing a DC there. Continue. Then we did a PXA. And I think the coloring broke. Well, it's kind of back here. So here we have the bin sh, which is part of the exploit. Meaning a part of this. Hit breakpoint. Right, so I hit this breakpoint with this 563, which is actually where it stops. And then I step another instruction. And we're back at the same. So we never leave it. 563. DS, DS. So every time I run this, I end up at the same spot. DSL. Yeah, I was stepping a line here instead. We still at the same spot. So it stopped. Maybe it should give us a clearer signal here that it did stop. So is this an infinite loop? What happened? Why did this happen? Is that just how it works, you know? So after str copy, we saw this. A string starts at before return from the function. Right, before return from the function. PXA ARSP. So we have the numbers of a string here. And RSP is here. And that's where I then try to set it. But so I guess that instead of this, so something is going wrong in this. And I see what I was trying to do, but I couldn't really get that nice message. So let's just quickly run the one that we have locally. So since this is a very short program that just acts on its own argument and nothing else, if we do it with EDB, we'll have to start it with EDB, right? Oh. Okay, but not now. So we'll have to open the program here. And I've been doing protostar. So let's do THM, buffer overflows, number 3, buffer overflow, and it is paused at the very start of the program. And yeah, I could find the functions here. I remember this. So I think I'll put myself like here. So now I'm used with Windows and x64 DBG, and I know that I listed functions here. Symbol viewer, function finder. Yeah. Right. I remember I have to click the first one. No. Find. And then we get the functions. And here we have main. So if I click main, it already has a breakpoint there as a start. And we also have this nice graphical view here. I didn't see that. It's a copy arch. Well, let's go back to main. So there's probably like nice shortcuts for things. So I can see, and also the functions are marked very nicely. It's pretty colors, prettier than the Windows one. Yeah, so I'm getting a bit tired. I'm thinking of getting something to eat. So that chocolate I mentioned, I'm actually hungry. I guess I still have half my bread left. It's getting dry. So here are the puts. The puts works fine, just prints a message. Then it does the copy arch, which with the argument. And this is what crashes, so we should probably go there. There, copy arch. So here we have the copy arch function. From the start, we'll push RBP, SPP, RSP, of course. So here's a string copy that breaks it. So it is on the jump back here at ret that it will. So after leave on ret, this is where we want it. So main is just here. And here we can see the names, if we could see them. I'm trying to mouse over this, but I can't still see the text, so. Buffer overflow. Main and copyright. So let's actually make the. I'm not looking at this code. Maybe just the two first numbers really. So now we can see the names. This is more interesting too. It's not that I'm not interested in this. It's just that it's more useful to see the names, right? So just making sure you can see. So we'll see if it pops up information here. We can make this a bit bigger, and we can actually see all the code in there. So whatever. So I tried making this text bigger too, but it's not really doing it. So what we would like to do is to run this program on the other machine and set the breakpoint on this line, on the leave line. Yeah, and you see the same thing as I do. It has the same memory addresses on this one. So if we set the breakpoint to 562 and we step, and we will see what happens to the registers right here. We don't have to step through all of the things. This is when it crashes, when it's trying to return to an address that doesn't work, you know, that's been overwritten. So just to be safe, I'm putting it here. I think it's breaking before the line though, but so it probably should be this one. But that's when I got this kind of loop seeming thing. It might just be the debugger rerunning the whole program. And it ended. It ended. It ended. It's very odd though. Especially as I knew even less then. So I'm just checking if I'm still online. It seems so. So I guess it's 13 hours now. So let's not think about it. Let's just enjoy things. It's Friday night. We're supposed to just live life, right? Though we need my last one here. Unless we don't realize, you know, when time passes that you actually need more food. So I'm like, well, I just ate. Nah, you didn't just eat. It was like, what was it, 19? Five hours ago. So the thing here, same addresses, we can use this to analyze. F2, breakpoint. We have a breakpoint. We need to set the argument. That's what I'm looking for. Working directory for the application. Open. I think that in the open there is arguments here. Will this break the breakpoints if I add arguments? That's the question. Application arguments. But this I cannot enter stuff in. I remember this. Feels like a bug. So the stopping. Yeah, we'll have to do this. 462. Let's open it. And let's do the argument of a lot of A's. Right? So I'm not going to do the lots of A's. I'm actually going to do an actual string, a pattern that is just 500. And we can see the position of everything. That's better. No, I want A's. I do want the A's. Do you know why? So let's just get A's in here. The reason I want the A's is because it's easy to see in memory a lot of 41s. So that's what I want now. I would just want to copy the lots of A's string. I think it's something like this, you know, just A's. It's not that important. We don't need to. Don't need to make it advanced. So just this, and opening it, and let's actually let's test this. Run until return. That was too far. But now we can see stuff. We have 41s in RIP, just as we usually do. But we don't have it in RIP. RIP is on the actual possession. It's on the last instruction, the ret. So we get the so this instruction should be ret. It should read A's into. Possible jump from, return to, yeah. So return to this. Good, good. This is good. So if you just change the parameter and do the same thing, so open, and instead here now we're going to do this. So and I'm not pleased with this, you know. I want to do it in GDB too, but it's good to understand the program and learn more. So this is how this ended. It's supposed to return to this, but it stops before. Actually, let's stop. So F7. So with F7, application encounter segmentation fault. So this is the same. If you would like to pause this exception to the application, press Shift F7. Okay. So let's do Shift F7. Debugger application terminated with exit code 11. So it stops it not to crash the debugger. Okay. Oh, my paste is still there. So let's open it again. And let's use the same one. Control F9. So I guess we should just do F9, right? Which will stop at the first breakpoint, which is, so why here? I mean, I can't anymore see this nice line that was here, you know? The starting of the function and the end of the function. Why is it not there? So now we could just F7 stuff, and F8 I guess is step over. So here we don't want to step through all of the puts commands, so I'm stepping over it. F7, F7, F7. This one we want to go into, so I'm doing F7, 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 F7. We don't want to go into string copy, so I'm stepping over it. And then we're at the very end here, closing up to the end. The puts here. Oh look. So this is what prints it. It prints what we have. I'm going to F8 this. Then we have a knob there. So let's just stab it, and this, when I run this instruction, let's just check what we have in the, so I'm almost forgetting that I have the stack down here. Let's check the stack now. So before we do the ret, so the first thing, the top thing on the stack, let's check our RSP here. So it is this position here, right? We start with 8, stop with 8 at least. 7 FFE 769 2DE08. So this is a stack. This data here, this data. So copy selection, copy address, follow address. So I will copy selection, and I'm assuming that come on, I did paste you. Okay. I think that notepad crashed with the stream, so it didn't have its colored bar or anything. It didn't work. So what we wanted here is the data. Well, look. We have all the formats. I didn't even realize. So one thing here is that we're running at 64-bit, you know? My tummy is so thankful to get some food. But this is interesting to see. So this number is much longer than it should be from 32 bit. It's double, of course. But this is what would be read into when we step F7, the next step here. This is what should be read into RIP. And it's kind of a crazy number, right? And we don't have a very big buffer here. But we still have the position of this. I'm just thinking it's not like aligned, but it's still the same memory address. It's just the first bit that's not there on the other one, on the 32 bit. But it's just instruction addresses. These addresses on the stack might be totally different. It's not the same machine, it's just the same executable, and it's on the same memory address, and this, I need to know that why. Well, let's actually take the opportunity to ask ChatGPT. Where is it here? So, when I debug a 32-bit program in GDB on a VM, on one VM, and in 64-bit on another VM, the addresses for the instructions are the same. How come? The reason you're seeing the same instruction addresses in GDB when debugging 32-bit program in one VM and 64-bit program in another VM likely relates to the memory layout randomization or lack thereof. Yeah, I was like, nah. A position independent code pick. Here's why this could be happening. So, address space ASLR is a security feature that randomizes the memory address of executable files, shared libraries. The heap, the stack, make it harder for attackers to predict. If it is disabled on both VMs, or if you're running static binaries, the program's memory layout, including instruction addresses, will be consistent across multiple executions or on different VMs, regardless of whether it's 32 or 64-bit. This can explain why you see these addresses. You can check if ASLR is disabled or enabled using. Yeah, I know. Static vs dynamic addressing. In 32-bit programs, statically linked libraries will have a fixed base address for instructions, making addresses consistent across systems if ASLR is disabled. In 64-bit, the default for modern system is position-independent executables, which allows the code to be loaded at different addresses depending on ASLR. However, if PI is not enabled and ASLR is disabled, you might get similar addresses. It's not similar, it's the same. Different kernels might handle ASLR differently, especially 32 and 64-bit. If both being a similar configuration, ASLR is minimal. These are... Yeah, I haven't restarted the machine, so I probably disabled ASLR and disabled it. And also the executable is definitely set to not use any kind of security features. Compiler can influence the layout of the program in memory. For example, if you're compiling, yes, it's the same executable. Info lock mappings. This will show the memory. So what about other programs using the same address? This does not seem logic to me. Both it is the same executable on both machines, and it is compiled to make learning buffer overflow easy. So all protection is off. Still, it's very odd to me. Yeah, it's intentional vulnerable. It's called buffer overflow. My goodness. Even though protections are off, I understand that it seems odd. The instruction addresses are the same between. Yeah, so it's not that it's 32 and 64-bit. Mostly it's just that it's different machines and it's the same executable. But what if there are several executables? So they can't just have one address that they like, right? So since it's using the same executable on both machines compiled without protections, this means the program is likely statically compiled or compiled, no pi. The code sections are binary, especially text section. It contains instructions. Will be loaded on a fixed address on both machines because there is no to randomize there for both. So in the text section, it will say, "Load me here." Is that it? I'm just scanning it. So of course that thing is not the thing. The address space are distinct, separate, even if two programs use the same virtual addresses, they don't interfere. So these address spaces are distinct and separate. So even if two programs use the same virtual addresses, they don't interfere with each other because the OS ensures their memory maps are separate. All the 64-bit systems have much larger memory space. 32-bit processors use a smaller portion of that space. Since both programs might have a base address in the lower memory range, they can end up using the same addresses. 32-bit program has its own isolated address space managed by the operating system. Yeah, so this is what I was thinking. Well, it's relative to the program, this address, you know? If that's the only logical solution, but when I checked it up before, I didn't see anything like this. This says it's a virtual address. That's a relative address. Why it's not conflict? You mentioned that other programs might use the same address, which seems logical. However, keep in mind that virtual memory allows multiple processors to use the same virtual address without conflict. Because the OS translates virtual addresses to physical memory uniquely for each process. Each process has its own virtual memory space, and virtual addresses are not directly mapped to physical memory. Thus, multiple programs can load instructions at the same virtual address, like for, but they also handle the translation to different parts of physical memory. That's why our 32-bit and 64-bit programs or other processes can run independently, even if they use the same virtual address for instruction. And this is the only solution that I could see before too, because I started the program twice in different ways before, and they had the same address, and that's not impossible. Like reuses, you know. I don't remember what I was doing differently, but something. Learning-oriented vulnerable programs. Since the program is specifically compiled for learning buffer overflows where protection is off, the base address of the code is likely fixed and same across different environments. And this is what makes it possible for us to do the same thing to a remote program on a totally different machine and have the same address. No ASLR input means the address of the instruction will remain static. This is intentional and make overflow exception predictable and easy to understand. Conclusion. But no one has mentioned this, right? So the reason the addresses are the same between 32-bit and 64-bit versions is that they're probably using fixed base addresses. Same address every time. Always ensures virtual memory isolation. So even if two programs use the same virtual addresses, they operate in separate memory spaces. This behavior is normal in vulnerable programs designed for teaching purposes. So this is great. Tell me more about how virtual memory works. You know, I did search about this before. We won't read this now. So I'm asking for short answers. I guess it's okay. So maybe this version doesn't have... So it swapped, right? It switched to another version. I don't think it's my midnight that it uses. Oops. Oopsie doopsie. It terminated. So it was time to go back to it, and then it was... So got a bit of this chocolate. So we have this thing here. So I'll just eat this. Oh, I'm still using the full path. I don't need to, I'm in the directory. $152. So let's look back. Oh, SSH is here. And the TryHackMe ones realized that they're off at once. The Hack the Box Academy ones, they were like on for hours, thought they were on for hours, and I couldn't control C them. Oh my god. So these batteries have about 4 hours and a bit more. So I have to switch for the third time. This is the fourth time, it's the third time I think. To switch gears. It's a long stream, I know. So it had the good taste of crashing, so that I will probably be able to upload to YouTube without problems, at least at 9:30. Alright. So now it's not good to have it there. So I'm going to reconnect, and we have a new IP. 60.107. Six additional names omitted. So user 1 password. Very useful thing to remember. Three. So so I guess that I'm using R2. And that we're doing the same thing, confirming that we have the same number. Right? We want to make it use this pattern and get an 152. So let's see what I remember now. So R2, well, so here I remember what I did with bow 32, which is another one. So R2D. Yeah. So actually, oh, that's funny. It jumped back. So what we're doing now is B for overflow. And we're actually not doing 55s and 66s. Well, let's do 55s and 66s. No, let's not. Let's actually not do that at all, but just put the string here. Right? So copy. I don't want to build on the other one. I want to make it from scratch. So and A is already done. So now we're going to do let's make that breakpoint DB. Let's actually do PDF at main, just from memory now. Remembered, and we can see the address. It is the same. Actually, it is not exactly the same. It is not the same now. And at 561 here, we have a knob. So is this fun? No, we're in the wrong function. That's what we are. So this function is called copyright. I think this is wrong. Yeah. So I need the my god. My brain remembers the commands. I'm almost annoyed at it. So PDF sim.dot, right? I didn't remember that. Sim.dot. So when I started now with R2, I didn't remember them at all. They're just popping back in my brain. That's good. So repetition and repetition. And you won't have to keep looking at the notes all the time. So here we have the same one, 563. Yeah, I was like, what? It's not the same? So we actually want to add a breakpoint. So db 0x 400 562, so that I can step the last one there, and let's do db to confirm. Break enabled. In module. So getting used to the names, they calling them modules too. Yeah, so it is 1 byte there only, the C9, and then this is C3, the machine code. So let's DC. And after we have DC'd, let's DR. Hit the breakpoint. Let's DR. And it's currently at 562. So let's DS. And let's DR. And we are currently at the RIP there. So if we step again now, we will probably not get anywhere, right? Because, well, it will go to 563, but it should crash and then it will stop there. So we really want to see the memory before we execute this next instruction. That did this reloaded the old frame, really, stack frame. And the next thing is just to hop to the next instruction to go for. And we will have overwritten this memory. So what we really want to look at now is what is on the memory address RSP. And I'm checking the notes because this command didn't just pop into my head. But I have it here. PXA at RSP. Exactly this is what we want to do. PXA. If I knew what it stood for, print hexadecimal annotated hex dump. Yeah. Print hex dump annotated, I get. Maybe. And then the address. And when we do at RSP, it should work. And we should get the same numbers here. So the colors were not friendly today. But let's compare this to our pretty UI program. And well, let's actually scroll that one down and lift this one up. There, so we can compare here. 0AF1, AF2A. So this is what it's pointing to. So when we run the next instruction, DS, this should be put into RIP because that's what return does. That's what ret instruction does. But we get an error, and when we print this again, it has not changed. Right? Let's compare. So it freezes it at this point. Like it's pre-checked that if I do this, I will error. And this is what's like odd, because all the other debuggers, they have just crashed with giving us the address, right? And this one doesn't do that. But I'm kind of thinking it's executable and not the debugger. Why? Anyway, we have the same numbers, you know, though I can't see them. It's 30, 41, 66, 31. So $30, 41, 66, 31. So I can't there. I have to use the arrows. So let's just do this reverse. 1, 3, 6, 6. Now 31, 66, 41, 30. And we 0x. And I will copy this instead. And let's just delete it all. Or rather up. And paste it there. And we get 152 from this too. So yeah, we don't need to do MSF Venom for this because we have code. We got code in the like task. I'm thinking that what I have now is better than the old one. But this bit we keep. So this is running it normally. This is in R2. And here we got segmentation fault as a text. Here we got signal 11. So we kind of could conclude this without actually asking ChatGPT 2, but I was like, why doesn't it say segmentation fault? Or SUGEN or whatever, you know. I like my last one better than this. This is actual code. I'll make a lot of new there, and then I'm going to scroll down and see if there's anything useful in here. We'll probably just delete this later, because I've learned things and it was quicker now. Yeah, and let's see here where we're at. I'm just hopping to the other window so I can see the address. F. Oh. So we're at another address here. Print knobs. Yeah, so this one, we just need to change this. So why have this here? Let's just make a new, prettier one. So what do I have in my paste? Nothing, I think. I'll just test it. All right, I know. So I had in my brain not to copy because I had something in my paste. So now I can ignore it. It was just the address confirming the number of characters. So actually, I'm not going to save any of this. I think I copied enough to somewhere else. Up to the line. Yeah, this is when I was like, what is this, a loop? Oh no. So here and everything down. So now I find the position and the string. Make a non-repeatable string. I'm doing all the steps here now. So we have confirmed it that we can crush it with this number of characters. We did do that, and let's copy all these 3 lines. So So using EDB 64-bit and R2 32-bit numbers at ESP position at ret instruction that causes segmentation fault. Actually, this is too long. Oh. For some reason, this program will never actually run the ret instruction. At normal command prompt execution, well, at we get 0x000. Let's do a correct number as the address. When run, and well, EAP, let's do RIP EAP stays pointing to the ret instruction. Why? I'm thinking we'll just send this to ChatGPT. It already has a bit of information about this one. The situation your scrum suggests that programming counter submitted before the ret instruction is fully executed, potentially due to corrupted and invalid return address being pushed onto the stack. Invalid return address. Yes, it is invalid. Context. Why the ret instruction makes queues. If the CPU hits a ret instruction, it first pops the top value from the stack. Yeah, so it never changes that either, the stack pointer. The stack pointer is not changed. This is what confused me before with this one. Remains unchanged, but the ret instruction causes a segmentation fault. Here's a more focused explanation. Pops returns from the top of stack. In your case, no, the value is not 0x00000000. It is. Let's get that darn value. for 64-bit and giving it all the information for 32-bit, giving us a but requiring more thinking, as it should be outputted in the error. Well, requiring totally messed up the characters there. Thank you for the clarification. Do we trust it on anything? Oh my god. So, do you see what it says here? This is a series of A's. No, it's messing it up with before, what we had before for them, but yeah, I think it's time to like get a new one, because it's messing things up and connecting weird bits of the old stuff. I don't know if it's worth reading it, because we can't trust it anymore anyway. Yeah, so it's getting the buffer overflow, it's just not getting the actual value there. So it is not this is not the input. Yeah, it's messing things up. So let's just ignore ChatGPT and continue, because we got a bit more information, did we? This is why very odd. Let's just say odd. So this time I noticed why it seems like it's an endless loop there. It's not really going anywhere. It's not actually executing it, the instruction. And that's why it doesn't get the value loaded into EAP. Very strange anyway. So let's actually, in between these, we run it. So right, I run it here now. That's not my intention. Let's run it here. So let's do the same thing again, which is a bit annoying. So I want the output to be from this. I'm not going to do it all again like that, you know. So there, your mouse has moved. Your mouse has moved. This is one of the funny quotes. But I'm annoyed at all the extra information I don't want, you know? So this is probably the thing, right? That I didn't understand before. So it's setting this address. invalid address from for 5E9. So it's trying to analyze things there, but it can't do. So let's continue. We didn't get the same thing here. It's different. It's another version, of course. So let's do PDF main, or rather a PDF copy arg. Let's do both. So we have the nice colors and everything. So PDF at main, and then do PDF sum dot copy arg there, and then we want to make a breakpoint on this, so let's db 0x 400562. Let's do 3. It is still good enough, you know, it's before the instruction runs, and then we can just run it. So let's DC and it will stop there. And now we want to check both memory and registers, so dr for registers and pxa at esp for the memory. And this is not right. It's all F's. So let's see here. So this is correct. So we probably should maybe step 1. Oh. Okay, I see the error. So it is RSP. Yeah. So now we have the correct data. So let's just compare. I just actually did enter the correct name here, did I? So we did dr. We stepped 1 step, did dr again, and here we did RSP. Yeah, so I did RSP at once here. So I thought it was not, but okie dokie, I was wrong. So I didn't think of it before. Now we're going to step 1 step and then do both the memory check. So I suppose the ret instruction should load this, right? The question is if it doesn't do it. Well, if it's an actual address, then it might go better. So ds for stepping 1 step, and this will get the segmentation fault, and it says again it is a breakpoint as if it's still running, which because it didn't really do the instruction, and it's address 0. So when we do dr, we will have the same values, and RIP will still point to the same thing. And when we do the PXI, we still have the same values. So nothing changed. So here, see where I did the wrong. So we got the exact same things. Now let's just confirm the last bit. This is the last bit. Yeah. So we have prettier colors on our one than this. So that's the only difference. And the colors, they will not show when we copy this anyway. So let's copy. There. Copy. And we're going to paste here. And some of my notes are a bit wrong now, but nothing that really matters. So this will just delete because it was me typing the wrong character. I want a new line in between these to make it easier to see. So it stopped and did never really pop the old AP RIP off the stack. Stopping. Stopped. Using EDB and R2. Let's just we don't have to do that bit. No, using is correct. Oh gosh. Using the number at RSP position since RIP is not popped, but causes the segmentation fault, but still a segmentation fault. For some reason this program will never actually run the right instruction. We can run DS and DC infinitely. Infinitely. Let's go to the start. I didn't look at that. So this is why it breaks the syntax. So I usually do this to make it prettier so we can read it easier. That's an actual string. So let's see here. Yeah, let's keep this data here, this timeline running in R2 with so now let's break this up so it's more readable. The PDF main, these are kind of important so to see the program structure, right? So I'm keeping them even though they're not like necessary. They only necessary for that. So here we run it to the breakpoint, then we check registers, memory, then we step one step, we hit this, we check that in memory, that is the same. And I totally understand why I got so stuck on this before. I'm not still sure if what the reason is. Let's continue. So the next step is to run. Let's actually prepare what we're going to do here, right? So the exploit we had from the task, it is up here. So let's actually move this. Control exit. So the task gives us shellcode to use. Code to open a basic shell, and this information, so it's time to use it. So we have the shellcode, we have position. So we have position 152, shellcode O equals let's actually there. Let's do pi or something. No. It looks prettier. And what else do we have? R2 command. So it's kind of obvious this is not really a code. So calling this here, copy, just to have it correct, and it is. Let's do this, I guess. argument. So from the task we also have a calculation here and the suggested way to run it. So let's just quickly look at a few things. Now this is all of it. So we're just supposed to read the text. We also have suggested. Come on. Yeah, this had a few problems in the syntax department. This is like, okay, so this was just syntax, and these two, and these two, and these two, and these two. Very odd. And these, of course, are supposed to be right. I remember doing this before. So, and this one, and this one. Let's actually remove those. Now let's do this to make it easier. Python C print 90, well, 30 knobs, and this, yeah, there's actually space there. So if I plus, we get that, and then we have the code, and here we have another one of those, and also these characters. So let's Control H this character to this. So let's go to the next ones. No. There. So what about this one then? Yeah. So replace. Oh gosh. The end ones are not the same. Oh gosh. We got them all. So why am I redoing this when I already did it? Because it's fun? I don't know. Because it's late. So this is already checked. So 48. I don't want to read it all again. I'm assuming it's correct. Then we have 41 times 60. Just adding some empty space there. And then we have, this is where we're supposed to put the address. So this is our like actual command. So now we know we have 500. So I'm going to change this. So let's do 10 here, and let's do this to a calculation here, and we want this to be 152 minus the number of bytes in this is 1, 2, 3, 4. Let's actually calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 30 minus 10, because it is, I put 10 A's here. Why they're A's, I don't know. Well, let's keep them A's then. So we know if we end up in the wrong place, right? And these together before the address should be that. So the next thing to add here is the address, right? So we need the address of the shellcode, and we won't know this until we do this. So let's set these to well, I guess I'm typing 42. I'm sorry. I could have changed to B's, you know, but we're going to use this anyway. So 41's here and 42's here. Yeah, this is also 41, not an A. Still program name. No. So this bit is wrong, because this is an argument. So actually let this be let it be like that, and a full command, and we will do this bit and this bit, you know. So actually there. I guess I'll do a SH here so we can see those, and the argument is dollar parenthesis. Oh gosh, so I have to undo just to see what it actually did. So delete, then dollar, then parenthesis. Good. And then we're going to paste hold this thing in there. Backslash x 42 are placeholders for the address. there. We have the position, we have the code, we have the address, not yet. So full command to put this in memory to find the address to jump to. Whatever. Full command to put this in memory so that we can find the address to jump to. Whatever. This is worse. There. No, it's 2 sentences. Whatever. I'm getting used to being down in the corner instead of the normal place a lot. Yeah, so it is. Time is flying, you know. It's almost 3 a.m. I'm starting to get a bit tired. I can't sleep all day tomorrow, you know. I'm a mom, an adult. My mom wanted me to come over to help or something. So number of knobs, shellcode, random data, number of random data, memory address. Yeah, so we suggested command, right? So let's just copy this as it is and hope that I did it correctly, right? Actually, I'm hopping to the page and I was like, better add time. We just got there, so we could add an hour. So hopefully we will finish this one, but there's 40 before the hour is out. Yeah, so this is where we want to go and play. So let's queue and let's do a few lines so that we can see where we are if we're scrolling easily. R2 DA buffer overflow Python C. I'm not going to do it all again. I'm going to do DB. Copy. Paste. And we're going to do DC. And we're at the breakpoint. We can see the A's and the B's after the payload. Looking good. 10 A's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the scary spot, right? We're going to do DR and we're going to do PXA at RSP. And we see the B cell there as we have planned it to be, right? So when we run the next command, we will like break this. Or rather nothing will happen again because it's a bad address. So what we want to do now is to actually change this, and let's do plus 100, and maybe that was too much, was it? I'll also try minus. I'm getting confused here. Yeah, so now we're seeing the correct, we see the knobs now, so we're supposed to do minus. So let's do a position here. So my only problem now is that this is a long address. And we have 4 only. 1, 2, 3, 4. You know, we can't represent this in 4. So when we look at the registers here, we can see that some of them have longer values. So we would need to put this much data in there. Right, so we need to use all of this. We're not using 4 Bs now, we need to use 8 Bs, right? And we can also see all of the blues here. All the blue selection. So this is just 4 Bs left from, well, this is from the example. It uses this, right? But this is not correct for us. So this is thinking work needed, you know? So here we're going to actually, well, let's actually do that. And let's this one be, well, let's not change anything more because then the addresses will change and the memory. We don't want to redo it, we just updated this to be a bit more accurate to our actual data. That is actually 64-bit, it's not 32-bit. And then we will also need a bigger address, right? So we have here the address of some of the knobs. We can do a bit of other, let's do 20 here. We're still not seeing the start of the knobs, so let's do this. So there we can see the start of the knobs, right? So we have the start of the knobs. So we can like do somewhere there in the middle of something. So maybe this address. Also, let's actually copy this because it's a part of the thing. I'm not going to save all those addresses, right? So here we have the start command, and running the command. Very, very pretty comment, right? So we know that this last one, 160, was suitable to see all the knobs, even down to this. And I guess for prettiness sake, we should change this to actually be correct to our new command that we put up there. So these are like me testing how far back do I need to go, right? So let's just delete those. And we have a line in between. This is the actual where the RSP is. We can see it here though. So we don't need this one too. So let's delete that one. So we don't have more than we need. We can see the DR. We can see that we hit the breakpoint. We can see us adding this again. We can see these characters messing up the output again. So I think it's easier to read this way, so I think it's worth it. So the only thing now, of course, we need to change this to be double 2. So if we would have run this, this would have been the output. We would have had 4 more B's here. And we're setting the hitting the breakpoint. REP has lots of 41s. Nothing else is overridden really. Let's just confirm what we think, which is that if we were to, let's just go down, DS step, it actually worked this time. Look. So we actually ended up. This is interesting because this worked. The other ones didn't work. How come? And also now we have 4 only. I think this is so funny. That's what's so funny. So I changed it. DR and RIP is actually there. It's just the 42s. Well, let's undo whatever changes I made then. Now we're redoing this. There. So I removed the extra B's there. And these were just zeros before. Let's just put it back. So this was annoying. So I thought this would be the way, and then I changed my mind, and then I was suddenly wrong. So let's just look at this now again. We didn't look at the memory, right? Oops, oopsie. So let's run this again, and we see here that it now sits at new position. So D83, D83, 0000 zeros. Between there's so these were not actually zeros. They were the ones that are before D83. And D83, yeah, so it did read them all. Oh, I get it. I get it now. It's because it's backwards. So these zeros are actually a part of the address. So it is supposed to be all of them. Anyway. Sorry. So well, it's fine. It's fine. I'm not redoing it. Yeah, I was thinking, since these are all blue, they will all be red, right? Since this seems to be 64-bit and all the addresses are this long, Take a deep breath. Maybe I shouldn't be awake anymore. Anyway, let's this is the most important, interesting bit of it all. So we're going to copy this and let's put it here. This is not really necessary, you know, but it's still what? Yeah, all right, so that's the problem. Yeah, so this will break it, so I'm just doing that. So we have a DS, we do a DR, we do this again. We can now see that this is changed compared to here where we had all of this, and we really should have all the B's, but then we would have to change it all, and I really would like to rerun it, and I don't want to do that because now we have an address, right? So we just select one in the middle there, and we're going to go with this. That's why we have an address to use. We select an address in the middle of the knobs. There. Address. So, new command. And I'm going to copy the old one and we'll add the address to it. Over here. Nah, I missed this. It would be off. There. R2. So all of these. Oh, so these ones I didn't change back, which is good, because then I don't have to change them. But we did actually not use it here, so 1, 2, 3, 4. So the same here and there. 4 B's only. This is what we run, so let's go with it. As I don't want to rerun. So we have to reorganize this. This, and let's there, easier to see. So if we go \x on this, 70 \x e2 \x ff \x ff \x ff \x. So enough. And all of this needs to be do this. I convert endianness. So we have 70 e2 ffff 7f. Control C. We're pasting this instead of this. So 1, 2, 3, 4, 5, 6 we have now. And this is the type of address we have here. So 1, 2, 3, 4, 5, 6. So there's zeros before this. But they're just there. They're just there. It seems. So should we put these to 0? Let's test run it, right? I'm curious if, since we're overwriting, there might be other numbers here, though. Yeah, I'm going for safe, right? So 2 extra zeros there to make it finished at the top end. So we won't see those. So now let's copy the full command. Let's abort. Let's paste the new command. Let's run it. And this should give us a shell, a normal shell in the middle of this when we run it. I've seen it before. So DC. We don't set any breakpoint or anything. So so we did get a signal for error here. 1, 2, 3, 4, 5. Yeah, something went off here. So we did not check any bad characters, right? I thought that we kind of had that in there from the start, but we didn't do it. So let's just redo it quickly without my last second nulls. And we didn't set any point or anything, so it's still the same. Just wanted to confirm it's the same thing. So it's really supposed to crash at the end, but it should hopefully give us a shell first. What is signal for? I think ChatGPT can handle that. What is signal for? Illegal instruction signal. So to execute an invalid, unspecified, or unsupported instruction. Sig-ill. Yeah, so I'm starting to get too tired. I wanted to finish this. But it is 3 a.m. 3:11. And I've been streaming since 13. No, 20 minutes before 13, I think. It's like 12:40. What's that? So at 0:40 I had streamed for 12 hours. So it is now 14.5 hours. That's crazy. Why? You can't stream for 14.5 hours. Why? Why am I doing this? Because it's fun. Yes, I took the opportunity when my kids finally went to play with each other, you know, and actually continue this for a bit longer than I could before. So I don't that often have an opportunity to do this, just focused. well, focused with getting food for my kid and everything, and now they're asleep. I think there are. One of them is definitely asleep. So there's a program that echoes your input. So let's step through it the same way. So we didn't do it the same way, you know. So we're quitting, and we're doing the same one, and I think I will add this. So there's the bad chars to check, of course, for the address, and we can just test another address, so we can test the characters, but they will all have null in them if we do this. But this is also at the end. I'm just quickly reading their code, but their code must be okay. 41s and NOPs shouldn't be a problem. 70, you know, if FFs were a problem, that would be a problem. I don't think so. All the addresses have that. And these are just at the end, so if these are cut off, it's not the whole world. So I don't think that's a problem. So let's put the breakpoint to the address that I don't remember. There. See what's free this week. I apparently have Epic still running since yesterday. Yeah, I have not checked this week's. I usually do it on Thursday early. Right, we haven't tried running it in there either. So I'm just going to paste it and do that, then do DB, and then do DC, and it will hop, and we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5 characters, but what these are, you know, doesn't say how many bytes it is really. We hit the breakpoint, so we're going to look at DR, and we can see that the instruction pointer that is pointing, RBP is overridden with ACE, and let's check the PXA. Yeah, PXA at R. Oh, not an at. RSP. And there we have. I have to open the notes. So we have 70 E2 FFFF 7F. So it's hard to read these. Oh, that's not better. And then we have 0, 0, 0, 0. So it's all in there. It's all in there. And apparently 70 is P. Lowercase p. It looked like anyway. I can't see it that well. So that reminded me I should probably highlight something. So I'm just starting Twitch to check. Yeah, so I have a stream that expires in 0 days. Let's just do a quick highlight of it all from start to end, and let's click OK on that so I can do it tomorrow. So there, done. Because it might expire before I wake up tomorrow, and that's annoying, and not very, you know, it's not a big problem, and now it's done. There. I'm just checking who's online. Oh, Finn's online. He wasn't here before. I'm just checking who's online. Oh, what? What did it unmute the tab? I don't know. Oh. Yeah, so Theo is also online. Birth weekend, but it's gaming. Yeah, so if there's anyone doing cybersecurity stuff, I will read them. But I will finish first. I want to do this before we do other stuff like sleeping. So, confirming I'm on the right screen here. So we can see the address is there. So if we were to just do one step now, DS, what happens? We now hopped to the address of this. So if we now px, let's just well, let's pxa at RIP. So we have knobs, we have our code, and I think we will fit a bigger exploit here too. But the one that they have, so our jump worked. It worked perfectly. And if we just DS this, you know, let's put a breakpoint on this. Okay. So let's db there. So db, it's added, and now we just do dc to continue to that point. So we're at the breakpoint. Let's check. Actually, let's do pxa at RIP again, and we're just at the string there, right? So I want to just like continue, but I know that this will take a lot of like space. Let's let's actually do a new breakpoint at not C0 but B E and DC there and XRP. So now we're in the middle of the shifting. We're still executing things. So let's hop to C4, right? And let's DC. Hit breakpoint. Let's check where we're at. So we're closing up to the end of the code. Very much the end of the code. So let's just do the S now. And that didn't hop us forward, did it? So we're at the same spot? No, we're not. We're not at the same spot. So DS. So I know that sometimes the one here, which shows us this doesn't change, even though RIP obviously changed because we got another printout, right? So now we're just a few characters here. It's just these. DS. And a lost DS. And now it should have executed all the code. Right. Yeah, so I think this is probably correct. So let's DC this now, and it will crash because it will continue trying to run instructions that are not instructions. So we're going to quit, and we're actually going to use this command, but we're going to remove the R2 bit. Right, so Control A to the start of the line. Let's remove the R2 bit and actually just run this now. And of course we have to dot this now. And dot slash. And floating point exception. Okay, so it failed. So we didn't check for any bad characters. That's the only thing we haven't done. It's kind of late, and since I want to continue, I want to see what someone else has done with this. So let's see. So THM buffer overflows. Yeah, so I'm really falling asleep now. You might not see it, but I'm kind of tired. Yes, I think we checked something up before because it was messy. But then I felt like, no, I need to learn more. So let's skip that and learn. So, oh my god, it's very, very big. So can we see number 5? Metasploit. Oh, pattern create. Okay. Yes, they have 152 too here. So we're on the right one. What? 144. What did they do? So let's see if they had some similar problems to ours. Manually finding the offset. Certain text we will once again be using GDB to find an offset where we start. We know the buffer is 140 bytes long, however. There will be saved registers in between the buffer and return address. Well, this is not anything you can trust. So to try and find the offset, we need at least to go highest 140. Looking for 41 in the return address. Yeah, so this is my problem. I never got this. I never got this from this box. I didn't get this from the box. Though I did get when I used 8s, 48, 41s, ace. Yeah, 8. I should sleep now, right? Yeah, so they added one more here, and then they got this number, which is the lost instruction. With 6 byte, we get as a return. We offset is. We can also find the same 6 bytes. So how did they get the conclusion here? So here they're getting the instructions address. The ret's address. Here they have run Python A. Yeah, so I didn't run it with GDB. That's true. It might work better. So this is funny. Why did they do this but not? Yeah. So I never got this at all. So maybe GDB is better. Metasploits. This is what we just did. Could not find. Okay, they had some kind of problems with it. They're going to send a string. Let's actually compare it to ours in pattern. So I was sure I didn't have any 6s in there, but I did have it. It's just definitely formatted very differently. So we have 664130 as the end. So definitely different. Yeah, so we didn't get this. We got the actual 152. Crafting our payload. Utilizing a knob sled in front of the payload. So we did a knob sled. We added 10 A's in between the padding here. Okay, so this is, yeah, I know I googled where this shellcode comes from before. So this is probably the same place. We can look at this later. Let's see if it's the same. So I do want the machine code, not this. Yeah. Let's confirm. Let's actually check the time. That's more than enough. So we have 48B6. So we don't have the same. So they have used something else. Which is, since ours didn't work, you know, this is why we're looking. So they used something else. Let's see if it's similar. I think it's longer. No, what am I doing? Yeah, I'm definitely a bit tired. So this is the wrong one. I'm looking at, supposed to be looking at this. Oh my, I'm tired. I'm just going to scroll in the notes here to my disassembling of the one we're using that we got from the TryHackMe page. Oh right, I moved it down. So this is how short ours is. Right, so ours is 489B 2F. Yeah, it's so much shorter. So it's not the same. It's not the same. So let's give it a new. Let's do a new test. So second, try using. So I will give up soon because I am tired, and oh gosh, that's my tummy. So let's see here. So 1, 2, 3, 4, 5, 6, 7, 8, 16, 32. So apparently I can't calculate 32 plus 16, but 32 plus 8. So 32 plus 8 is 40. 40 plus 8 is 48. So 48, 49, 50, 51, 52 characters. We have 52 characters here. So so since the room has code using, so I was going to put it here, but since we had a fail, there, and we're copying this into here. There, and instead of 30 it's 52, right? 152 minus 52 minus 10. So we have lots of knobs still, meaning we won't have to change the address if we don't want to. It should be okay. Yeah, I'm thinking it's okay. So I'm actually going to copy this bit, and I'm just gonna run it. A bit ugly, just putting a dot slash here. And this one didn't crash. It has bin sh in it. I'm assuming that I'm still me, but it didn't crash. So this might have an actual exit in it. I didn't look at the C code. But the other one was very short, 30 characters. This is 52 characters. But it didn't do anything. So it has to use the suit bit, you know? I mean, starting a shell, that's the point. Okay. They're going through steps. So they're exiting here. That's why it doesn't crash. Which is kind of nice. Name one. Okay, so it's using... So this doesn't seem name one. Char name two. So I'm going to go in a quick bathroom break.
Making of a shell code for a 64-bit Linux.
Let's do this.
1 Aurélien.
Meanwhile.
2. En français. 3 December 5, 2019. Spoiler, a quick return to basics with an article that takes us to the basics of software exploitation, making a shellcode on a 64-bit ARKit. The other day, while teaching a class at INSA, I presented students with a method for making their own shellcode. For those unfamiliar with the term, it is a string of characters containing binary code that can be executed on a machine. It must be different depending on the architecture on which it will run, but also on the OS for which it is intended. My transparencies then showed as an example the creation of a shellcode on a Linux, for a 32-bit architecture. The binary executed was the most classic of shellcode, opening a command line. And obviously, I was asked the following question: what about 64 bits? Here is a small article to answer the question. It details the creation of a shellcode allowing to launch /bin/sh if you have a Linux and a 64 bits processor. Gerald at Pixabay. Code C. If we were dead good, we could of course write the shellcode directly in machine code. But few people speak of code fluently. Even assembly, a translation of opcodes a second more readable, is a language which is not very widespread. Tradition has it, therefore, that when we write a shellcode, we start with a code in C, which we will translate into assembler, then into machine code. Writing code in C is optional, but has two advantages. 1. It allows you to define a target: what is our code going to do exactly? 2. It allows to have an executable that we can disassemble, translate into assembly, for example, thanks to GDB, in order to see how it is done. Casse Pro at Pixabay. Target. The following program will launch a shell, through the use of execv. It will serve as our target. It represents exactly what we want our shell code to do. Hashtag includes dio.h. Hashtag include unist.h. Hashtag includes lib.h. Void main. Char asterisk name 2. Name 0 equals /bin/sh. Name 1 equals null. Execv, name 0, name, null. Exit, 0. When calling execv, the system will replace the current process with the one corresponding to the execution of /bin/sh. If this operation is successful, the instruction flow is interrupted to continue in this new process. If this fails, execution will continue with the call exit, 0. In a main like ours, the call toExit, 0, is useless since if exec failed, the program would terminate naturally anyway. But the purpose of a shellcode is to be injected into the memory of an attacked process to be executed, i.e. by buffer overflow, but not only. As we have no certainty either on the success of execv, or on the contents of memory after our shellcode, we prefer to force a quiet termination of the process by a call to exit, rather than to do so. Let anything do it anyhow. If we wanted to be cleaner, we would have to do an exit, 1, but as we generally do not want to attract the attention of monitoring by error return codes, with a 1, we lie to it saying that everything is fine, with a 0. The compilation. We compile with GCC, then we run the binary and we observe that we have indeed opened a shell. Arsu yes at vbox/documents $gcc shellcode.co shellcode. Arsu yes at vbox/documents $/shellcode. If you want to observe the disassembled code with GDB, I advise you to compile with the following options. 1. Static compiles in static mode, so as not to depend on external libraries, and at the same time, will allow to decompile the code of exec since it will be integrated into our binary. 2. GGDB allows you to get more information in GDB, such as the name of functions. 3. No stack protector allows you to remove the protection against buffer overflow set by default at compile time by GCC. On the one hand, because we don't care that our shellcode is protected against buffer overflow, on the other hand, because it increases the assembly code that we are going to obtain, and that we want to go to the essential. Go through the assembly. Now that we know where we are going, we will write the assembly code corresponding to the C code. We come up against 2 constraints. 1. Know the address of /bin/sh. 2. Get rid of external libraries. The /bin/sh string. It is not possible to know in advance the address of the string /bin/sh. We will therefore have to cunning to recover it. Interestingly, since we are on a 64-bit architecture, it is possible to directly store the string /bin/sh, in its hexadecimal form, in a register. /bin/sh in hexadecimal gives 2f.62.69.6e.2f.73.68. As we are on a little endian architecture, this will give 0x68732f6e69622f. Finally, since this is a character string, we will add the empty character, 0x00, at the end, so we will store the string 0x00687332f6e69622f in a register. We can then pusher this register on the stack. The string address will then be the stack pointer address. Exec. The second constraint is the obligation to free ourselves from any external libraries, because we are not sure that they are present. We will therefore have to go to the source of the calls, in our case to exec and exit. The exec function is quite a special function. It requires asking the operating system to perform process control tasks. As our user process is not capable of making these kinds of requests, we have to make system calls. A little search in the system call table of the Linux kernel tells us that exec matches to system call number 59, i.e. 0x3b in hexadecimal. By convention, when calling a system call, on Linux, the parameters are passed via the registers in the following order: RDRSI, RDX, RCX, R8, R9. Likewise, by convention, the system call number must be in the RAX registry. The system call is then made via the assembly instruction syscall. So we need to put the address of /bin/sh in 30 register, the address of /bin/sh in 30 register, and 0 in the RDX register. We also need to have 0x3b in the RAX registry, which translates into assembly by MOV $0x3b, %RAX. MOV $0x0, %RDX. MOVABS $0x00687322f6e69622f %R8. Push %R8. MOV %RSP, %RD. Push %RDX. Push %RD. MOV %RSP, %RSI. Syscall. MOV $0x3c, %RAX. MOV $0x0,
So
%RD.
why are they doing two
Syscall.
syscalls?
Exit. As before, exit is a system call. It therefore works in the same way as exec,
Exit.
i.e. its only parameter will be
course.
in 30 register, and its number, 60,
Yeah.
i.e.
So they've added
0x3c,
this to the
must be
end.
in the register RAX. Its
Which
assembly
was
code will
in
therefore be
RS2,
MOV
may not
$0x3c,
crash.
%RAX. MOV $0x0, %RD.
So
Syscall.
why don't they have the
If you want to use GDB to
machine
disassemble
code
exit and
here?
observe its code, you will find that this is
I
tedious.
want that.
Exit calls
I
_run
want this.
_exit _handlers, which itself does a lot of things before calling _exit, which ends up doing the syscall by putting 0x3c in the RAX register.
It's kind of long.
Final code. Now that we have all the information to write our code, we can concatenate it together and write the code in assembly language. To facilitate, we add the few decorations that will allow us to have an autonomous ASM code. .section.text. .global_start. _start. MOV $0x3b, %RAX. MOV $0x0, %RDX. Mavabs $0x00687332F6E69622F% R8. Push %R8. MOV %RSP, %RD. Push %RDX. Push %RD. MOV %RSP, %RSI. Syscall. MOV $0x3C, %RAX. MOV $0x0, %RD. Syscall. We
I'm
convert to object
tired.
code with as, then we generate an executable file with LD. Since we are not using an external library, LD will just do some decoration, that is, the header, the entry point, and not much more. Arsu yes at vbox/documents $as oasm.oasm.s. Arsu yes at vbox/documents $LD oasm.asm.o. Arsu yes at vbox/documents $/asm. Upcode. Now that we have our assembly code, we can finally switch to machine code. Each instruction must be translated into machine code, a sequence of 0 and 1 understandable by the processor. You can use the Intel documentation for this.
So I didn't do that
Gerald at
before
Pixabay.
here.
But as a good computer scientist is a lazy computer scientist,
Okay.
we will use objdump, which will do it for us.
I was like,
Objdump is a command line program
but
for
they're
displaying
doing it,
various
like,
information about
backwards
object
too,
files.
I'm thinking.
The option we are interested in is D, which allows disassembly. Each instruction is split into a line, which begins with its address, then its hexadecimal version, and finally, its assembly code. Arsu yes at vbox/documents $objdump dasm.o. asm.o, format deficure elf 64x86-64. Deassemblage de la section.txt. 000_start. 0,
Yeah,
48C7C03B0000000 MOV $0x3B %RAX. 7, 48C7C20000000. We will get the hexadecimal. This is our shellcode. \x, we can then test our shellcode. For that, we will use a small C code. By declaring a function pointer and giving it as value the address of the shellcode, we will be able to execute it. Hashtag includes dio.h. Hashtag includes string.h. Int main, int argc, char argv. Unsigned char code equals \x48 \xc7 \xc0 \x3b \x00 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 \x48
Okay.
\xc7 \xc2 \x00 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 \x49 \xb8 \x2f \x62 \x69 \x6e \x2f \x73 \x68 \x00 \x41 int ret equals int code ret. To compile, you must use the following options. 1. No stack protector to remove the stack protection automatically set by GCC. 2. Z exec stack in order to mark the program as allowing an executable stack. Arsu yes at vbox/documents $gcc testop.co testop no stack protector Z exec stack. Arsu yes at vbox/documents $/testop. $exit. You may also need to install the exec stack package. And there you go. Our shellcode works. Remove 0x00. Our shellcode is still far from ready for real-world use. The presence of 0x00 in it can cause it to be truncated when copying with a function like
Pandatongue
strcpy.
says.
An alternative
you're
must
still
therefore
on?
be found for each problematic instruction. A MOV
I
instruction
know,
containing
I'm
the
sorry.
first
PhD.
0s can be replaced by a push, followed by a
Do
pop.
you realize how many
In our
hours
case,
this is?
MOV $0x3B %
Nine
RAX
and
ET
a half
MOV
plus five and a half.
$0x3C % RAX are problematic and can be replaced by push
I'm
$0x3B
15 hours
pop
stream.
% RAX and push $0x3C
It's like 3 a.m. over
pop
there.
% RAX.
Yeah,
An instruction
yeah.
putting 0x00 in a register can be
far
replaced
soon.
by an X or of the register on itself. We therefore perform a first
But
replacement.
it's Friday.
MOV
But I have to get up
$0x0%
tomorrow too, of
RDX.
course.
X
You're
or
a
percent
machine.
%RDX %RDX. And a second. MOV
Yeah,
$0x0% RD.
But I'm tired
X
now,
or
and I
percent
can
RD
feel
percent
how
RD.
my brain like
Finally,
goes.
our string
So
itself ends with
I
a
just
\0.
TDS this.
To avoid this, we will use the
So
string
actually,
// bin
let's
/sh,
pause this.
which we will put in.
Right, I'm not reading this now. Yeah, so I'm going to actually run this and see if it works on this machine. If it doesn't, there's no reason to test it. If it works, we have a big
You're making me
chance.
tired. I don't know if I can stay till the pizza delivery.
So what time is it for you? So they use test upload. Asmir.
Almost 10 p.m.
That's very late. So let's paste the code. Oh, sorry. So I did make it. I was going C, but then I was like, it's ASP, and then this is what happened because I'm tired, you know. Teststuff.asp, teststuff.c. So we have the test there, and we're going to compile it with their command. That's why I used it, you know, the same name. We're just gonna paste it here, and we're going to run it, and we have a shell. So this code should work. Right. It's confirmed it works on this machine, but it didn't give us user 2. We're supposed to get user 2, and didn't give us a shell either. So let's continue checking this one out. -5. Yeah, I guess I'm +1. Am I? 10. So 4. Yeah, that's correct. So we're 6 hours apart, and that's you're -2 and I'm +4, right? So 6 hours time difference. I'm like, what am I doing? So there you go. Our shellcode works. Our shellcode is still far from ready for real world use. The process of null, and it can cause it to be truncated when copying with a function like string copy. An alternative must therefore be found for each problematic instruction. A move instruction containing opcodes with serves can be replaced by a push, followed by a pop. So let's see where he ends up, right? I'm assuming we'll get a new one to test here. So no nulls. So there. Let's nano the file again. Okay, yeah, I know. I did rename the file, you know. So let's just. I should have just deleted it. I'm not saving any of that, right? But I can see all the nulls here. There's a lot of nulls. Null. At least 8. Oh, 9. 11, 12. A lot of null. So I should probably learn how to do that automatically. So there. Let's GCC it again. Run it again. We're still getting the shell. We can still use it. And we exit again. So and after you can create your own shellcodes. So first of all, let's compare this to what I tried already, which is the same, I think, because he said he got it from this page. So here. Are these identical? No, they're not identical. So, this is definitely not the same. This is the one with lots of nulls in it. This makes me tired. So I tested something that was not even close to being functional, right? And I have to count again. No, I'm not counting that, I'm counting this. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 14, 28. What can my brain do now? Let's just do it simply here. 20, 29. After 29 we have 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. After 39 we have 40. I'm not tired. I'm not tired. So instead we have 40. So 40 instead of 52. Not 0, 4, 40. And we're going to delete this old shellcode, which is filled with nulls. I didn't even notice. And we're going to copy in this instead. And let's put it in the right place. There. So. And this one is supposed to exit, so it will not crash. So if this works, I'm going to start it first this way. If this works, we're happy. And we go to sleep. And we sleep for a long time. I get the floating point exception again. And I'm going to check what this dude says instead of just hopping along. But this is out. This is at the end. I've tested this code that it can run on the machine. So 5 is kind of low one too. We haven't checked for bad characters here. That's part of the problem probably, but I'm too tired. I will continue tomorrow after this, but I'm going to see what this dude does. Let's see. Creates a pattern. We've done this. We've done this. Here's a link. So I think I copied this. This is not the right one. Or this is probably the right one. 6 Bs. They're doing 6 Bs. So 100 plus 40. Yeah. 42s. Now the only thing we need is the address of our payload. Yeah, so I might have ended up outside my knobs. So I'll have to test it. But I don't think so, because it's not that long. It's just 10 characters difference. And I put a point in the middle of my knobs. And the knobs are like 100. Almost. Now the other thing we need is address of our payload. Yeah, so we're going to redo this to make sure that we have an address in the knobs. And these guys, they did do this dude. They do bad characters. I don't think so. So let's search bad. So there's no bad in here. There's no bad in here. So let's just undo that. Where were I? Where? 2? My god. Oh my god. Okay. GDB, finding offset, registers. Oh, they have a cheat sheet at the end. So this is what they're doing. Craft the shellcode, list available shellcodes, F format. What? Oh, okay, so they didn't actually use that one. They used shellcraft. Install pawn tools. So this task is applied with code, so you kind of assume it will work. Yeah, so now I'm curious to see just if someone else did it. So let's do something. Click something. So -2. No, -2. Install Mono. What? I'm hungry. Mono. So this is not the right one. Yeah, this is buffer overflow prep. TCM buffer overflows and buffer overflow prep are two different ones. And that's the wrong one. So what about this one? This is buffer overflows, the correct one. So we're going for the second to last task. Let's see if these. So I don't understand people that actually copy all of the room. Task 8, buffer overflow. So this is the one we're on. This is just the page contents. Question 1. Read the contents of the secret txt file. They're doing 158 A's for some reason. And if they do 159 A's, they get a different one. So we know that 158 bytes, we override a 6 bytes long return address. So why did they do it like this? It's not pretty. After many attempts, all failing with a legal instruction error, I found a shellcode 40 bytes that works. This is the one I tried now. So Python shellcode equals len shellcode 40. So they put it in Python just to find the length. That's lazy. I'm tired and I counted it. The last item we need to complete our payload is the return address of the shellcode, 6 bytes. Our payload will be like this. So I have 10 random characters only. The payload 90 times 90, well, 90 hex. So let's look at our payload and look at this one and see if they are the same. Because he said this worked, right? So let's copy this and let's paste it here. And let's compare the actual imported bit of it. So I can say 0.5. So copy here and let's paste it here. Oh, there. So they do look very, very similar, right? It is exactly the same one. Just confirming. And this one says it works. Run. Right. Yeah, so we just have to double check our position again. So this one says this works. So let's just see here. Take care of the editor between nup and the shell final payload. When executed, the program actually spawns a shell. As you can see, we are now allowed to access a secret because let's upon tools. Okay. So they're doing this after this. Now I'm curious why they're doing this, but let's see if we get it. Let's just test running their command, right? Because it's the same memory addresses. So yeah, so it works. So let's just check the nups. That's what it has to be, because that's the only difference. So ours is the only change is that I have 152 minus 50, meaning 102 here, and they have 90, and they have nups afterwards to 22, and I have 10 here. And we have a slightly different address, but it is only 28 bytes difference. So let's look at, let's find our correct one, right? So let's just go down to the end and hop over here. And I didn't run it with R2 yet. I just tried running it without R2, because if it would have started, I would have had it quicker. But we'll have to fix the new nup place. Finish the bear. So I guess we will PDF at no. Memory stopping to work at sim dot copy art, and that I just did to get an address there at the end. Let's do 562. So let's put a breakpoint at this. There, db. This is one reason I restarted, so all the breakpoints from last time are not left there. And then we just DC to run to the breakpoint, and then we DR to see the registers, and we PXA at RSP, and we can see we have an ops here, and the address that we used was 70. Let's see, E270. It's still in the middle of the knobs. It should work. So let's put the next breakpoint like here. So let's do B DB no, wrong one. But not 0, but a bit later here in the execution. So, oh, actually, let's do C. C. C8. Right? Let's go for C8. And let's do a DC. And let's check. It's jumped to the correct execution. It's executing, but it's not giving us the shell, and I don't know why yet. So this, it might be the address. There's something in this address is not good, and theirs is better. And they have, I'm just going to click back and see. They have 9.8, so we could do 9.8, no problem. It's still in our knobs, so we can do 9.8 if this doesn't work. It's just meaning 70 hex would be bad character, because it's the only difference. They're also using knobs afterwards. That can't matter, can it? If that matters, I'll faint. Oh no, we're going to DR. We see that our RIP is there. We do PXR RSP again. We see that we're just at the very end here. Actually, let's just DC it. So now we got it. It worked. But I just run it and didn't work. So since this is run in here, we're still user 1. Yeah, so it crashes afterwards. Signal 17 now. So again, so why did it work better? We got the shell even if it just run one thing. It did run the my command. So if we // this, I'm getting a floating point exception. So let's change the address to the one they used, which is 98, which was also in our naps. Okay, so 70 is not a functional character. Yeah. What's the file name? I don't want to break this just because I can't. Let's check notes. I have it in the top of the notes. We have it. So I'm going to test this again, but I want to make sure that I can get to secret.txt. So I'm going to just there. We got permission denied. Right, because we're running it in here, so we can't do it here. So now it actually exited because it was running the exit of the program, which is good. So yeah, so I'm going to change these to naps. And let's do in who am I. I'm not supposed to be user 1, I'm supposed to be user 2. And I think that they said it worked, you know. So I'm going to run theirs once more. And I think that there's a reason why they're where is it? Yeah, here. Why they're going set array UID, right? Because this didn't really work. Didn't really work. Right, so let's exit. And let's do this one. And let's do who am I? User 1. And I'm also going to, let's just exit this. So it didn't really work. It's not fully functional, as it's not getting the ID with it. Yeah. So we need this UID. So last time I think I did with Amsterdam, right? So let's actually do a quick test, right? So now we're doing history. My God, history grep MSF Venom, and I wanted Linux. Not a reverse TCP. No? Seriously? Okie dokie. So let's do this one. But we're not gonna grab Windows. We're gonna do Linux, and then we're gonna do grab SH. All the reverse shells should hop up too. Yeah, too much. Oh god. Yeah, I was actually already here. So Linux HTTP. Yeah. HTTPS, 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 TFTP. Oh, x64 exec. Yeah, so Linux x64 exec. Then there's x86 exec. So instead of this, and we're not doing calc, of course, because we're Linux. So we're doing .sh, and let's do it in, well, I guess C is okay. We don't know what bad carriers we have. We didn't test it. So I'm kind of thinking 70 now. That's a tiny one. Well, it's not that tiny. 87 bytes. So no, I did copy. So there. This one, the other one thing won't work. So, well, I guess we'll copy this whole thing. And to there. Begin to put the synapse. There's no reason to have this thing. Let's put a plus there. I guess the reason to have this is to make it a bit more flexible in case it adds stuff. Whatever. I'm just thinking that this is bigger. And we want knobs with H7 characters. Oh, I'm going so hungry. So I'll have to stop because I'm hungry. And it's 4:30. Yeah. So I guess. Right, so I kind of know where we are in memory now. So we can do like 54, right? Just a number there. So we're pasting this. That's not the right thing. Ah, that's annoying. Extremely annoying. Why did it happen? And I need to remember how to delete all the line. So copy seems to be starting to not work. So copy, paste, and we do /. Why? It just runs. Yeah, so I did put a random number as execution. Oh. I didn't mean to do that. I meant to do this. So it should be the same number of characters. Why? So yeah, that's mine. So the problem here is that who mine is still user 1. So if I don't continue now, I will have to redo. So I'm thinking I will just have to do this last bit here too. Or I will just, yeah. So we need to install this to create code. Set UI before the shellcode. So let's just steal this bit of the code, right? Let's just steal this bit here. So they're checking the length of it, and it's 14 characters. So we don't have to install this program tonight, right? But it might already be installed on our machine. So I'm going to go through this and just fix a few things. So we need a -14 here, and we're going to add a plus paste there. And now we have it. So now we can cat secret .txt there. So there was nothing wrong with the shellcode, it just was not complete. And we will have to dig into this more, but not at 5 in the morning, right? Because it's 4:35 now. So I will of course need to install. So we already looked at this before. One of these linked it before already. The pawn tools. I don't know where I got it from. I guess we'll add an hour. Why? I'm going to sleep. Right, so this was this other code. Well, this is actually the code we're using, right? Yeah.
Fixerbot says, "Welcome Raiders. Finn with Gun brought 6 friends to the party. Go drop him a follow."
So
Finn with Gun says,
it's a bit late here.
Yo,
translated from Spanish.
Yeah, I'm crazy. Do you know how many hours this is streaming? I started at 13 or at 12:40. I started streaming at 12:40. Now it's 4:36.
decided to raid. You've been streaming for so long.
Thank you for the raid. Thank you for the raid, Ben. Fun. Hope you had a great stream. What were you doing? Did you do some buffer overflows? Were you inspired? Or did you do the web stuff or something? So I'm just seeing if these guys did another solution.
Keep up the grind.
Yeah, shellcraft.
I did a medium HDB, haha.
Ah, nice. Nice. Ah, yeah, so I was just about to stop, you know. Right, we need to put this in there. We need to put this in there. So, copy. You know, raid. Then I can't stop, can I? So, I don't know if I can think though. We're going to have to look at. I stole this one instead of installing Shellcraft here. But I've been having odd things. I want to do a actual real bad character check on this one too, and other stuff. But I don't want to do it today because I'm asleep. Yeah, and this one uses the same thing to get the set a REUID. So So seriously, why do we have to mention this when it's a sued one? But I guess we'll have to anyway. I'll have to explore it, but not at 5 a.m. I was just saying I'll have to stop streaming at 5 in the morning. So let's calculate how many hours. So 9.5 plus 6 hours and 10 minutes. So that's... Yeah, and it was like 9:45. It was 9:45. So I've been streaming for 16 hours. 16 hours. Just running in, getting food and getting the kids food. And doing buffer overflow the whole time. Oh. I'm a bit tired. So I was going to raid you. Who am I gonna raid now? Who am I gonna raid? Yes, I'll be continuing probably Monday. Yeah, so look here. I have you up. I had you up here. So now it's just me twice. No? What happened? Whatever. We'll have to look at the list